We are now at the data transformation module, where we are going to cover how to use GenAI for data-related operations when you are trying to transform datasets themselves, detecting schemas, generating metadata that is consistent with the new dataset, generating validity rules or policies for the new dataset, and more. Let's take a moment to cover the lessons and topics in this module. Welcome to this module on data transformation with generative AI. That is, how to use GenAI for data operations that involve changing the structure or the schema of an existing dataset. What is going to be our main focus in this module? Well, for example, it's how to detect schemas in datasets if we don't have that information yet, and how to convert those datasets when we need to transform data at the end of the day. So finding out what is the target schema that we need to transform the dataset into and actually carrying that out. Or for example, how to both generate metadata for existing datasets, but also ensure that the metadata that we have will remain congruent across new repositories, or if we change the dataset and we have to change the metadata with the same terms and definitions. In other words, we can have different terms in different metadata repositories. It's not just about the existence of metadata, but the congruence of metadata, and doing this with GenAI. Or for example, how to generate rules that dictate the requirements for data validity, as well as policies such as data retention policies or access control policies, and localizing these for specific apps or repositories. In other words, cascading down the general data validity rules or the general policies to specific repositories or specific applications to translate them into specific infrastructure, if you will, going from generic to practical. In this module, we are going to have three main lessons for this purpose. The first lesson is about schema conversion and mapping. It's about using GenAI to actually convert a dataset from one schema to another schema, for example, mapping specific fields and converting formats of specific fields. It's about finding out what is the source schema, what is the target schema, what is the mapping between the two, and actually carrying out that transformation. Then, lesson number 2 is going to be about metadata generation and consistency. That is, using GenAI to document existing datasets that we may have in terms of fields, policies, sensitivity levels, and other characteristics that are worthwhile to note down in terms of metadata, and ensuring that those metadata remain consistent across various repositories. Again, same terms and definitions for all metadata. And lesson number 3 is going to be about validity rule and policy creation. That is, using GenAI to automatically calculate what are the rules to enforce the validity of that dataset in order to have high data quality. For example, we need a certain value for this field, this value must be within this range, and so on, but also defining the general policies that may aid us in a variety of areas, such as data retention policies, access control policies, and so on, and translating those to specific applications and repositories. For example, if we have a general data retention policy to keep data for 90 days maximum, how do we translate that to a specific web application that we may have, to a specific mobile application, a specific database, and so on, taking the theoretical and making it practical. So as you see, this module is going to be all about data transformation, how to use GenAI to help you take one dataset from a specific format to a target format. Converting and mapping schemas using generative AI. What is schema conversion and mapping? Well, they are activities that we need to perform in order to transform a dataset, maybe to integrate that dataset with another one, or to merge the data, and so on. We need to know where we are, where we need to go, and how we're going to get there. So what is the general process, not even involving GenAI? Well, first, we have to analyze the source schema in the target one. We have to know exactly what are the formats that we currently have and the ones that we wish to have in the future. Then we want to establish a mapping of some sort from source fields to target ones. For example, we may have a dataset that is already in the current schema or the desired schema, but the only thing that doesn't match is, for example, a country, right, in terms of a field, because the codes that we use are not the same as the codes that we need to use for another dataset. So in that case, we just need to map the source codes to the target codes. And the same for any field that needs to be transformed. In a worst case scenario, every single field in a dataset. And then finally, we carry out the transformation itself and we convert the data according to those criteria. And how does GenAI help for this specific use case? Well, for one, it can automatically map these schemas, right? We can provide the source schema or have it detect the source schema if we don't know it already, and also have it detect the target schema, and it can recommend what we need to convert, right? We can say, for example, hey, we need to integrate this dataset with this dataset. Can you calculate what is the target schema for this dataset and how to convert it? And it's going to tell us what we need to transform. Or for example, adding context, right? GenAI can add additional relevant information or metadata with conversion notes, for example, for more transparency in the process. That is, if we provide backup information, and tell it why we need to transform this specific dataset with that additional information, then GenAI can make a more informed estimate of what is the source schema and the target schema and what is the recommended mapping. The higher the information that it has in terms of context, the better job that it's going to do as for many other tasks involving GenAI. What are some examples of prompts that we could use for converting and mapping schemas? Well, for example, we could say, hey, we suggest a mapping of every single field between the source schema, copy and paste, and the target schema, copy and paste, or the source dataset and target dataset, and have it automatically detect the schemas if we don't know them. Or we could ask, for example, please convert the data from this target dataset to this target schema. So as you see, they're very simple operations. We're being specific in terms of what is the specific schema, both in the source and in the target, what is the mapping, and how do we perform that conversion. What are some best practices here? Well, for one, we want to stagger the process if we can. That is, instead of doing one pass for the detection and conversion all in one, maybe we do a first pass just to detect the schema, we double check it, and then another pass for the conversion. Remember, it's very easy to overwhelm an LLM, especially when we have complex datasets, large datasets, and many tasks to be performed at once. And also, we have less transparency if we do it all in one go, right? If we have one pass to detect the schema and the mappings, then we can double check those before we proceed. If we do everything in one go, we have no transparency whatsoever. And then another best practice here is explicitly confirming the criteria. That is, what are the exact fields for the source schema and the target schema? And what are the criteria that we want to use when converting them? Do we want to round numbers or not at all? Do we want to ignore the empty values or include them and convert them to a specific equivalent format, and so on? What are the specific criteria for the conversion? The more specific we are, the better the conversion, naturally. Then we do have risks and limitations as for many other activities, right? So what are some of these? Well, first, we may lose context. That is, if we don't explicitly prompt for adding notes, then the process is not transparent, right? Why was this value converted to this other value? We don't know. So you can ask the LLM to include a new format that has the justification of why it made that conversion. So you can ask for an additional column, for example, with a justification for every single conversion in terms of those fields. Because if you don't ask for those, then GenAI is not going to tell you why it made a specific conversion, right? The more transparency, the better. And then we may also face ambiguity here, right? Especially if we have certain features that have ambiguous names or duplicate names in other repositories. For example, if revenue means one thing in one dataset and it means another thing in another dataset, then the conversion may be erroneous, or it may incorporate irrelevant information, or it may be confusing because it's using conflicting sources of information or conflicting definitions. So the more that we can be specific about the fields and what they mean, the more that we can tackle this, but ambiguity is always a present problem. In this lesson, we are going to be converting a dataset in terms of its schema. And unlike the previous example, which ended up being very complicated here, we just want to convert the format of a specific dataset. We want to convert it from CSV to JSON, for example. Very simple, right? So we're going to take this dataset, we're going to open it up in Sublime Text, and we are going to copy paste it as a CSV here, right? Let me check if it says table anywhere, because we want dataset and not table, because we're going to be converting it to JSON, right? So we definitely do not want to try and convert it to JSON and to tell the LLM to output a table at the same time, because that's just going to be a disaster. And then we're just going to say, please convert this dataset to JSON format. Again, compared to the previous operation, this one seems deceptively simple. So I am cautiously optimistic in terms of this one, okay? So it's thinking, it's noting down what is the JSON format. Some fields are numerical, but should be represented differently in JSON. That is fair enough. As usual, let's see how the first pass does and then refine the prompt, right? We have something which is very interesting here, which is that it's getting it right at first try, or at least it seems to, right? So we have how many orders here? Is it 20? No, it should be 17, 16, I think. Yeah, we do have repeated IDs though. Yes, so this dataset was not that well generated, but this is an interesting thing, right? Is it going to detect it and fix it or not at all? So we can see here that it converted the first 4 orders. Again, we're using a small LLM. I don't know whether it does have, the mental bandwidth, if you will, to take care of all of these at the same time, but this actually seems reasonable, right? At least for these 4. right? So order, customer name, customer email, shipping address, order date. So it seems to be formatting everything in the appropriate manner, and it does seem to make sense, right? Let's take the first one and copy paste it here just to compare, right? Just want to make sure that this really does make sense. So John Smith, it changed it to John Doe, John Smith. The order date is different as well. Is this the same order though? Not really. It seems like it did change a lot, the data. Washington, D.C. Is there something that actually says Washington, D.C., or did it just, yes, it improvised this. Okay. So let's do the same. And let's do this. Let's chop off half of these and just do the first batch. Okay. Please convert this data set to change format. Please do not change anything in the original data. Just change the format. And let's see if the results are better now. Again, LLMs tend to change the original data, so asking it to not change the format is kind of a challenge. This is one of those operations that you should definitely not do with an LLM, because the LLM always changes the original data, but still, we are trying to do it with an LLM. So, interestingly enough, it did not change the format. It's literally just outputting the same orders as it originally did in the same exact format. So this is useless, okay? Please convert this data set to JSON format. Please do not change anything. Okay, so what may be happening here is because how I phrased it, right? I'm saying output it as JSON, but do not change anything in the original data. Yes, but what I should say is do not change anything in the original data and output the exact same fields with the exact same values as JSON. Now, I'm already guessing that because I phrased things this way, we could have a situation where there are values that need to be converted, but I'm saying do not convert those values, and it's going to be an invalid JSON. But I just want to see how we can get it to respond to the prompt and to start generating things that make sense. Because if you can get, this small LLM to generate successful results in JSON format, then everything else is an improvement over this, right? You can just have a longer context window. You can just use a bigger model in terms of the number of parameters, right? This is not enterprise grade by any means. This is me just playing around with a dummy version of the LLM and telling you how it's usually done, right? So in this case, it did not output all of the orders. And by the way, JSON is a difficult format for the LLMs, right? Because it's nested and it can easily fill up the content window. But out of the two things that we have here, these two initial orders, I'm going to increase the window size a little bit, and I'm going to chop this off just to make sure. So we have John Smith, order 1001, John Smith at example, 5th December, 123, Main Saint, Anytown, California, 94502, product 501, wireless headphones, electronics, 179.99, 8.5, 86.79, credit card standard delivered. Okay, beautiful, right? Okay, perfect, right? So it transposed this data to the JSON format and it works flawlessly. But here is the thing, right? Again, because this is a small LLM with a small context window and a smaller number of parameters, it's not able to take all of these and convert them to JSON format, right? Because it's a lot of data to transpose. And it's important to notice that the more complex that the prompt is, the harder it's going to be to get a good result, right? So for example, if we know that LLMs have a tendency to change the original data and we try to not change the original data with our prompt, you already know that that's a very specific prompt that may fail in a lot of cases, right? So you may have situations where if you're using this in an automated pipeline, you have to repeat it 4 or 5 times until you get a satisfactory response, and then it's ready to, move on to the next step. So when we're talking about the pipelines later, we're definitely going to need to have a scenario where we need to repeat this multiple times and get the best out of those results. So as we see, GenAI can help you convert schemas and perform the mapping of fields, but it is very important to guide it in terms of how you want the conversion to be done, because anything such as ambiguity in terms of the fields or the terminology can end up in an erroneous conversion. Let's talk a little bit about using GenAI to both generate metadata and keep those metadata consistent with other repositories that you may have. When you are transforming a dataset, it may be the case where it doesn't have metadata, or it may have metadata, but you need to change those metadata to fit the new transformed dataset. So in either case, we are going to cover how to both generate metadata, but keep them consistent with other existing repositories. Welcome to this lesson on generating and keeping consistent the metadata in your datasets with generative AI. Another crucial task, be it when we are transforming datasets or just in general, is documenting our data, right? Generating metadata about the formats, the meaning, the sensitivity level, and many other aspects of a dataset that may be relevant. But more than that, ensuring that metadata stay consistent across repositories. In other words, you can't have a specific definition for a column or a field in one metadata repository and then conflicting information that says that the format is different in another repository, right? So consistency is key. And what is our general process here for generating metadata and keeping them consistent? So first, we want to define the global terms and the meanings for metadata. There are certain things in your organization, such as the definitions of profit, revenue, and so on, where you must have a global definition. Because if the definition changes by geography or by data repository, then that's just a recipe for having inconsistent metadata everywhere. So you have to start with first principles and with general terms and definitions, which are going to be global and applies to all metadata. Then we want to document the datasets that we have with metadata following those global terms, right? We want to cascade those global definitions down to the specific metadata repositories. And then, optionally, we want to monitor the various metadata repositories for consistency, right? That is, comparing various metadata repositories, for example, and asking yourself, hey, are we using the same terms? Are we documenting fields with the same format, the same length in terms of characters, for example? Is it a one-liner for this field and one full paragraph for another field? Is it justified? Are we including useless information in some of these repositories, and so on? Making sure they are consistent and congruent. And as usual, GenAI can help here, right? How? Well, by automatically documenting data, for example. GenAI is great at summarizing, at gathering insights, at detecting formats, and more. It's great at writing about something that is already in text format, right? So all of these are crucial when we are documenting for metadata. So just like you would use an LLM like ChatGPT to generate the boilerplate for a contract, for an email, for a document, and so on, you can definitely generate the boilerplate for metadata. And if you already have a template or a structure, and you feed it that structure, and you ask it to generate new metadata for a different data set using that same structure, then even better, right? It's great at generating text about text, if you will. And then it's also great at harmonizing terms. That is, LLMs can understand the variations in the same term, right? Such as, for example, revenue or profit, in suggesting changes that should be reflective in all repositories. For example, are we talking about top-line revenue or bottom-line revenue? So GenAI can detect when you are using different definitions in metadata and suggesting one global definition and fixing all of the metadata repositories, fixing, if you will, that don't reflect that global definition. What are some examples for prompting when you want to generate and keep metadata consistent? Well, for example, you can say, hey, please analyze this dataset and generate metadata descriptions for each field in the dataset. Please also classify the data sensitivity in specific based on these levels. Maybe you have, for example, high level sensitivity, low level sensitivity, maybe specific categories such as PII or personally identifiable information. And if you do, you want to feed those categories so that when the GenAI generates that metadata, it focuses on those specific categories instead of inventing new ones. So it's kind of translating the generated metadata to your specific language, if you will. Or you can prompt, for example, hey, please compare the metadata in this repository, and highlight the discrepancies. Maybe in terms of the actual syntax, the text structure, but also maybe different definitions that these metadata repositories use, for example. And what are some best practices when you are prompting for this type of operation? Well, one of them is to incorporate contextual information. Remember, the more information that a text generative model has in terms of context, the better that it's going to perform its task. So by asking the text GenAI model to take into account business rules, domain expertise, existing metadata repositories, and similar, it can refine certain elements such as regulation or the sensitivity levels. A basic example, if you take a generic dataset without providing any further context information and you tell an LLM, please give me suggestions of what regulation may be affecting this dataset and how to comply with that regulation, versus saying, this is a dataset of financial transactions that contains credit card data and personally identifiable information, and now tell me what regulation may affect this dataset. It's completely different, right? As for many other GenAI tasks, the more context information that you provide, the better the results. Again, as long as the context information has quality, is updated, and is not wrong. And then another good practice is just asking for suggestions, right? GenAI can not only harmonize variations of the same term, but actively suggest the definitions that will be the most natural for people and that will be easily usable across repositories. Instead of wondering, should we use this definition or that definition, just ask the LLM, what definition would you use based on the information that you have about datasets and metadata and so on? Or what is the definition that is the most accessible for people to immediately understand what this field is about? Or even taking one definition and breaking it down into two. For example, if people are fighting over the definition of top line revenue and bottom line revenue, why not have both fields and define both fields, right? It depends on the use case, and it also depends on how easily the people in your organization understand the term or not. And then, what are the risks and limitations that we have when we're using GenAI for metadata in specific? Well, one is that hallucinations may occur. Look, hallucinations are dangerous in general for any use of GenAI, but specifically when we're trying to use the same exact terminology across metadata repositories, they can be very harmful, right? Because if the LLM gets one thing wrong about a definition that is going to be used across all metadata repositories in the enterprise, then that error is just going to be compounded. Or maybe there's an error in certain repositories, but not others, about the same definition. But all of these can easily become nightmare scenarios. So you want to double check, you want to be careful with hallucinations, and you want to use techniques such as advanced prompting for specific fields and specific terms, or maybe even next level measures, such as, for example, having two parallel LLMs and asking the same task of both of them and then gauging the results and wondering if they're the same or not, right? It's added computational power, but it does give you added safety. You define how careful you want to be and how safe you want to be in terms of hallucinations, but you can always mitigate them, never truly eliminate them. So you need to be aware of them. And then there may be a training mismatch, right? Because if the metadata contains specific domain expertise or specific jargon that the LLM is not trained for, even if the LLM understands these terms, it may not be able to consistently generate metadata with those terms. Remember that the LLM and the prompt that you use must speak in the same terms. If the LLM has a different definition of revenue, for example, than the prompt that you're using, then you're never truly going to know what is the revenue in the generated output, right? And you can teach the LLM the specific definitions when you are writing the prompts, but with a context window sliding and a context degeneration, it may fall back to what it knows. So especially if the LLM is not fine-tuned on your specific jargon or your specific domain terms and domain expertise, it's important to be aware that it may fall back to definitions which are not the ones that you want to be using. In this lesson, we are going to have a fun example, which is we want to generate metadata to document the fields of a set of products. But what I did was I picked an example where you have a list of prices in these products which do not correspond to the definition of price in another table, which is the sales data table. In other words, we are going to need to harmonize the definition because they use different definitions of the price. But first, we're going to throw the data at the LLM and see how it documents those fields. And then we're going to look at the specific differences in the terminology or the words that we're using. So I am going to copy and paste this product information here. And again, in this case, it's not going to be the data set that is output. So we do need to change this part of the prompt. So what we're going to do is cut this off and say, please document all fields present in these tables. Please note down if there are different definitions across both data sets and harmonize those. Thank you. Perfect. Is it possible that I'm not getting good results because I didn't say thank you? Who knows? Let's see how it fares. So it's thinking, taking a look at the product table and the sales table. Okay, some fields are common. The product ID is shared. Both have date fields. There is a base price and tax rate column, while in sales, instead of separate lines, they have retail price. This is interesting, right? So it's immediately detecting the kind of tripwire that we placed here, okay? And this is good, right? Massive success. So it did detect that we have different definitions for the base price, retail price, and it's documenting those, right? Common fields, product ID, date fields. Good. What we can even do is, if this were an actual production of metadata for metadata repositories or whatever it is, we would do it in a slightly different manner. We would not have the numbered list. What we would do is we would have a list of every single field. And then in the field, we would say, this is the data format. This is present in these other tables with different definitions. So that's exactly what we're going to do in this second attempt. Okay. For each field, please detect the data format. And what I want to say is, please indicate what variations of that field exist. And what they are. And what I'm hoping here is that it's going to automatically pick up on the difference between the retail price and the base price. And then when it's documenting base price, it's going to say there's a variation of this called retail price and vice versa. Let's see whether it does that or not. I think that it's actually going to do it because it has already detected that in the first place, but let's see. Okay. So we do have a little bit of an issue, not an issue, but the formatting is not exactly in the way that we want it. That's not a problem at this stage because in this specific case, we're not trying to copy and paste something to a specific repository, but we may want to force a specific format, okay? Suggestions for harmonization. It seems like the transaction date is not standardized across these different repositories. That's fine. But what I'm worried about in specific is the price, right? Base price, base retail price. It's not giving me exactly what I want, which is the variation, okay? So harmonize those. Let's do this. Please output. So it's saying harmonize. I'm not sure that I want to harmonize it, right? But what I want is, please document all fields. Please describe one field at a time. For each field, please detect the data format, and please indicate for that field what variations of the field exist and what the differences are, right? I'm trying to say in as indirect a language as possible that I want it to note down the difference between the different prices, but I cannot say that, right? So I'm trying to say in a very generic manner for each field what variations of that field exist, because I want this prompt to be generic, right? I want it to be able to support multiple variations. Okay, so product ID, product name, base price, always in current format. Okay, so could also be something here, which is, I don't think that it understood what I was talking about, right? Because when we talk about variations, it seems like what it understood was variations in the format, which makes sense, right? If you take a look at what I wrote down, please note down the data format and note down variations. That's not what I mean. So what I mean is, please indicate for that field what other similar fields exist with slightly different definitions and what the differences are between those fields, among those fields. Okay. So now I'm going to run it again. And you can see how language can be tricky sometimes, right? Because I talked about data formats and then variations. And while in my mind, I'm thinking about the variations between the different fields like base price and retail price, what it understood was variations in the data formats. So sometimes you need to clarify certain elements of the prompt, and then it's going to be okay. I think that at this stage, it's still thinking about the specific fields and it's not outputting the final results yet, but we'll see soon. And again, you can see how the context window plays a large role here, because especially when it's having like these gigantic thought processes where we're asking for two things at the same time, right? We're asking for data formats and variations in fields. So what it's doing is the equivalent of a for loop where it's examining every single field in terms of the data format, and then it's examining every single field again in terms of the variation. So either you get a bigger LLM with a bigger context window, or you find out a way to break this into two different passes, or you find out other hacks, if you will, right? But the lesson is the same. When you're trying to do a lot of things at the same time, it may not work and it may break. Okay, so we do have the fields here: product ID, product name, department, base price. So it emitted the variations, right? We do have, for example, launch date, purpose, data type. So it's detecting the specific formats, is detecting the specific types. This is okay, but we don't have the variations here. Okay, so maybe it's an attention mechanism thing. Let's do this. Let's assume that we do one pass for the data formats, and then we do this other pass just for the relationships between fields, right? So let's omit the data format part. Do we mention the data format somewhere? No, we don't. Okay. Please document all fields present in this table. So let's actually do a pass where we say please describe all fields present, and for each field, please indicate fields which are similar but different and note down their differences, or describe their differences, right? Again, if we can't do it all at once, we do one pass for one thing and another pass for something else. It depends on the workflow that you have, right? Chances are you're not going to fully automate this, especially if you're talking about very sensitive definitions. But what you can do is you can get the LLM to do, a mass description of all of the fields in one pass. You take what you want from it. Then you do another pass to detect the similarities among fields and so on. Okay? So similar fields, right? Product ID appears in both datasets, different fields. Base price versus retail price. This is what I wanted, right? See the level of effort that it took to get this. Maybe it's because it's a very demanding process, right? Examining all fields in a dataset, the values, the value ranges, and then asking for the related fields. But finally, we got that, right? With the available stock versus the quantity. This is interesting. I didn't even notice this one, right? So product availability while quantity indicates the number sold or purchased. Okay, yes. I don't think that these ones are that related, but it's interesting, right? Because you just want the LLM to give you options. It may be the case where it outputs 5 possible relationships and you say, this one makes sense, this one doesn't make sense, and so on. Either way, it's better to have a lot and to have a lot of information to process than to have no information, I guess. Maybe if you have a gigantic data set, there is such a thing as too much information, but for now, this is doing what we wanted to, right? So in this case, we had to break it into 2 different passes, one for the data types and the formats, and another one for the related field, but either way, we did find that out. So as we see, GenAI can be very powerful in terms of generating metadata for your datasets. And our biggest preoccupation here really is the inputs that you are using in terms of the existing metadata, because the new metadata really have to fit the current format and the current syntax that you are already using. Let's talk a little bit about using GenAI to both generate data validity rules and policies as well. You may just want to generate validity rules in terms of a specific field, for example, being within a range, or you may want to generate policies related to data retention, related to access control, and a lot more. And if you have contextual information to help GenAI generate those rules and policies, it can definitely help you with all of these tasks. Let's take a look at how to do this. Welcome to this lesson on creating validity rules and policies for datasets that you may have, that you just acquired, or that you have transformed, using GenAI, of course. An interesting practice, usually in terms of data governance, is to define rules for data validity, or policies in terms of how to handle data. That is, what are the specific criteria to determine whether a dataset is of high quality or low quality, or who has access to that dataset in terms of the users in your organization, or what is the level of the security and privacy measures that we should apply based on the sensitivity level of the dataset, right? There are a lot of rules and policies that you can generate based on a specific dataset. And as usual, GenAI can help here. So what is the general process, not even including GenAI? Well, first, we want to define the key elements of data that matter to us. For example, if you have a dataset with customers, what are the data validity rules for those customers? Well, maybe they need an ID of some sort. Maybe they need a full name. Maybe they need a location, or not at all. Depends on the use case. But usually, depending on the specific use case that you have, there are going to be certain requirements for the data to be of high quality. For example, in financial transactions, a data validity rule is that the price of the transaction or the value has to be filled and has to be above 0, for example. That is mandatory. Or it may actually be below 0 if you are representing a transaction that is taking away capital instead of providing to a specific account. But either way, based on the specifics of your dataset, there are going to be specific data validity rules. If the data don't obey those rules, they have to be fixed. Otherwise, they are of low quality. As simple as that. You want to define what you want to focus on for these rules or policies. Then you want to define rules for the data validity itself, right? In terms of completeness, accuracy, and so on. Again, it depends on the dataset. The specific dataset may need to have certain values that are complete, so they can't be empty, or they may need to be timely, that is, they can't be older than a certain amount of time, or they may need to be accurate within a given range, and so on. Usually, there's kind of a common sense logic here, and you can even use GenAI to help you, right? But for specific operations that are performed on a specific dataset, you are going to need to have certain fields in a certain way. And those data validity rules simply tell you that. What do we need to have filled? What do we need to have in terms of values and so on, so that the data are of high quality? And then we define specific policies, which is a separate but also important use case, right? what are the data retention policies for this type of data, right? For example, if we are talking about public logos that you see on your website, you are not going to have the same data retention policies as, for example, for patient files, right? It's completely different. Or access control, right? Which roles in the organization should have access to this data set and for how long and so on. There are all sorts of policies for different uses that you can generate based on the specific data set. And then optionally, we may also want to define specific policies for specific applications or repositories, right? In terms of data governance, it's common to have a general theoretical policy, such as, for example, data with a high level of sensitivity, such as confidential, must not be kept for more than 90 days if they are not needed. But how do you translate that to the confidential data in a specific data set or the confidential data from a customer acquired for an application and so on? So at a certain point, you have to translate the general policies or the general rules and cascade them down to specific applications or websites. And GenAI can help with that localization, if you will, as well. So how can GenAI help in general terms? Well, first, it can automatically generate the rules, right? It's the simplest use case, but it is a powerful one. GenAI is very good at extrapolating from a data set what are the most important elements and translating those into rules. What are the features that must have values, in what ranges, and so on. In our example, if you have a data set of financial transactions, you may calculate what are the entries that may need to have a specific value or what are the value ranges. But you can also dump the data set onto an LLM and ask it, what are the data validity rules for this specific data set? That's it. And actually, in many cases, it's not going to tell you exactly what you need to know, but it's going to give you a rough boilerplate that you can work on. Because even with a financial transaction data set, it depends on what you want to use it for, right? If you want to, for example, calculate aggregate location data statistics, then the location must be filled, right? But if you just want to, for example, perform fraud detection, maybe you don't need location, or maybe you do. It depends on your engine. So it's not just about the data set. It's about the set of use cases that you have in your organization that use that data set. And again, a data set may be of high quality for one use case and of low quality for another use case, right? So the more that you provide context to the LLM, the more that it's going to be able to generate customized rules for that specific data set. And then localizing rules, right? As we said, GenAI can also be good at actually translating those generic policies into specific ones. So what you can do is you can take a generic policy, such as saying, hey, we have to delete data after 30 days, and then cascade it down to specific applications or repositories with custom code. You can even generate the literal code adapted to every specific application or repository. For example, if you have a mobile application and you have the general policy of deleting data after 30 days, you can literally dump the source code on an LLM and say, hey, what are the changes that we need to make in order to delete the data automatically after 30 days? Or if that application is inserting the data in a specific repository, then what is the code that you have to change for that repository to automatically delete the data after that period? What are some examples of prompts when we want to create rules or policies? Well, you can say, for example, please analyze this dataset and suggest validity rules for each field, right? The basic approach. You don't provide any context. You just say, hey, analyze this dataset and tell me what probably needs to be filled or what needs to be within a given range and so on. Again, the more information that you provide on what the fields mean, what is the context behind them, and so on, the better the job that the LLM is going to do. For example, with a financial transaction dataset, if you don't even have the field names, maybe it can extract some validity rules, maybe not. If it does have the field names such as customer name, customer address, credit card number, and so on, transaction value, the data validity rules are going to be even better. And if you provide the use case, such as, for example, we want to use these financial transaction data in order to train a fraud detection engine, then it's going to generate even better data validity rules. The general rule applies. The more context that you provide to an LLM, the better the results are going to be. Again, assuming that that context information has the same accuracy and quality as the dataset, because if not, garbage in, garbage out. Or for example, you can say, hey, based on this generic data retention policy, please integrate it into this app's code base. And then you copy paste the source code or the relevant portion of that source code. And again, it's not going to do everything for you, but in a lot of cases, it already does a lot of the heavy lifting and you just need to fine tune the details. What are some best practices here when you are prompting for this type of operation? Well, for example, being specific with fields and attributes. As we said, right? By default, the generated rules may be specific or not, and we may want that or not. But for specific applications, specific use cases, and so on, you want to explicitly ask GenAI to localize them. Do we want a general data validity rule, or do we want one for a fraud engine training use case? We want a general data retention policy or one for this application, and so on. And then confirming what is important. As we said, it's a variation of the previous one. For example, if you have a client field or a client entity, the name and the ID may be crucial. But is the customer address crucial? It depends, right? If you're doing email marketing, maybe not at all. If you're doing mail marketing, then it's crucial, right? It depends on the use case. Or for example, is having document ID crucial? In certain areas like healthcare or finance, it's absolutely crucial. But if we're talking, for example, about email marketing again, maybe not at all, right? So it depends on the use case and sector. High data quality for a data set is not global. It depends on what you want to use the data set for. So again, GenAI may not know this, so the more context that you provide, the more that it's going to be able to give you a tailored answer. And as usual, we do have risks and limitations when using GenAI to generate these rules and these policies. So one of them is that we may face a lack of consistency. Ideally, all rules and all policies are exactly the same. But if the context window slides, or there is context degeneration, or something happens in the middle of the conversation, then we may face rules with different values or criteria, right? So you want to always check. There are cases where if a conversation continues, the definitions of certain things slowly change over time. So if you are running, for example, 40 or 50 different tasks in the same conversation with an LLM, then the results that you get for the most recent reply are not going to be the same as the results that you obtained for the first reply. So you want to be very aware of how the context window changes and the context degeneration occurs or doesn't occur, right? It may also be the case where the LLM can run 30 or 40 operations and it still does the exact same thing, right? If that happens, it's okay, but you want to pay attention to possible changes in the answers that you are obtaining. Or if you are just precise enough with your prompts, you can also hedge against this, because the less ambiguity that there exists, the more that you are going to obtain accurate answers. And then another possible limitation is that the rules may be naive. Look, GenAI has no idea what is possible in practice. So in a lot of cases, it may suggest things like real-time deletion of unneeded data or things that are not practical in the real world because it's always talking in theoretical terms. It doesn't know what limitations your organization has, right? GenAI, by definition, LLMs, text GenAI models, are naive. If you ask it to build a rocket, it's going to tell you how to build a rocket, regardless of whether you are able to build that rocket in terms of resources and expertise or not. So GenAI, in a way, always tells you what you want to hear, and it's very naive. So it may tell you about generic rules that are not practical. So the more that you can provide information about your limitations, your schedules, and what is possible with the current resources, the more that it can adapt those data to the real world. In the final lesson in this module, we are going to talk about generating validity rules and policies. So essentially, what we're going to do here is we have a list of transactions, right? And we are simply going to generate the data validity rules in terms of the value ranges, but also maybe some policies already in terms of access control or data retention or others based on this data. And again, it may be the case where you don't want to generate all of these in an automated manner. You just want to get some work done and then build up on that work. Ideally, if we even have templates in terms of our existing policies or things like that, that could help as well. That's added context. But for now, let's start with the basic prompt. Please detect the value ranges and generate data validity rules for each of the fields in this dataset. That's it, okay? And now we can simply run it. And let's see how it does in this initial pass, right? I'm hopeful that this one is going to be an easy use case because we're just asking for one thing. And LLMs are very good at pattern recognition, so you would hope that this is one of the things that is easy to actually do. Okay, so the thinking part is done. So transaction ID, the value must begin with FT followed by one or more digits without any leading zeros. Yes, that's fine. Validation rule for the transaction date, it's a valid string representing dates within May 2023, right? We can see here that this is interesting because all transactions are from this month. So it thinks that the validity rule is that all transactions must be from this month, right? But at the end of the day, the only thing that we know is that it should be in this specific format, right? Year, month, and day. It doesn't need to be in this month, but because the whole data set is, it thinks that it should be in this specific month. Then naturally, if we have an amount, if it's positive, it must be greater to or equal than 0. And if not, it must be greater than minus 1,000. Should it be greater than minus 1,000? I don't know, because these are financial transactions, right? Maybe we don't have a specific amount. Or maybe if we are, for example, a bank, we know what is the maximum or minimum that we allow in a transaction without needing to break it apart in other transactions, maybe a certain number like 10,000 because of the currency transaction reports, whatever it is. But at the end of the day, it makes sense considering the data that we're seeing here. What we can also do is generate a first version of these policies or data validity rules and then add more data and then ask to refine those rules based on that, right? So that's something that we could also do. In fact, we can even do that, right? Let's take these data validity rules out of curiosity and let's see. Okay, so here we have minus 1,299.99. So this thing that says must be greater than minus 1,000, this is actually already wrong because we already have transactions that are more than this. But what I would like to do is, we have these rules, and I'm going to say the technical ranges and refine the existing data validity rules for each of the fields. And I'm going to try and mess with it to see if it's actually, if it changes or not, right? So for example, the value must begin with FT. So let's change it and let's call it, for example, EC. And let's see if it actually detects this change in the format of the ID. There shouldn't be any changes. It should make that change, but I want to see if it does detect, right? So what is this specific field? It's the first of all, right? The validation rule, transaction ID. Okay, let's start with FT. So all the IDs in my data seem to follow this pattern. No, not all of them follow the pattern. So it's missing this. Again, it may be the case where the data set is too big for the small LLM that we are using, and it doesn't make that detection. So what we're going to do is we are going to chop off some of these, and we are going to try and repeat this because I wanted to give enough attention to the entries that it does have to detect these errors, right? So transaction ID, let's start with FT. All transactions do start with FT. So here's the thing. There's something else that may be happening as well, which is LLMs are very naive. And when you give them certain directions, they don't doubt them. So because we are using these rules in a very declarative manner, like saying all transactions start with FT, maybe it's actually believing that as true, right? Even if there are facts that say the opposite, because we are stating all transactions start with FT, it's thinking, oh, they actually do, when in reality they don't, right? So that could be the case as well. So in those situations, what we could do is we could write down the data validity rules in a different way, or we could write something in the prompt that says that the current rules may be wrong. I'm going to try and do just that. So we're going to keep this small data set. Do notice that the current data validity rules may be wrong. Please assume that they are wrong by default and must be changed. So this is something that we can do, right? Because we have such declarative language in those rules saying all transactions must start with FT. We're also saying in the prompt, please assume that these are wrong and change them if they need to be changed, right? So, for example, transaction ID seems to follow a pattern starting with FT followed by numbers. In the examples, it's not FT. So that's irritating. It's still not finding that, right? But again, it could be because we are using such specific language, right? So transaction ID, value must begin with FT. There's also the situation where if a lot of entries start with a specific number, it's going to think that pretty much all of them do, right? Why? Because it's a probabilistic model. So they probably all start with FT. Even if there are small amounts of noise, they're not recognized, right? So what could we do here? We could go even deeper, right? Please assume that the validity rules are wrong by default and must be changed. Please consider a rule invalid if even one value does not fit it. Pay attention to detail. Pay attention to details. So we're already finding out what is the necessary type of prompting for certain operations that are very granular, right? Because since the LLM is naive, or since the LLM has a tendency to ignore low amounts of noise, we want to make it sensitive to the noise on purpose in such a situation. So transaction ID, the current rule says it must begin with FT. They all have 4 letters before the number, but there is a C. Okay, maybe the rule should be adjusted to allow any string starting with FT, not just specific lamps. So it did detect that there's a different formatted ID, but it didn't detect that it should be a C. It just detected that it should have a different type of string, but that starts with the same. So it did detect the error, but it didn't fix the rule in response to this error, which is not exactly what we want, but still it's better than nothing. So what we can do here is we can simply not take into account the current rules, and we can see what rules it comes up with, right? Detect the value ranges and come up with data validity rules for each of the values here, right? That's something that we can also do. Instead of taking into account the current rules, which could be an obstacle because it's going to be so fixated on the current rules, we can simply detect the rules from scratch every single time and then see whether they match the current rules or not. We could do that, right? Transaction ID, a unique identifier, it's alphanumeric and has a mix of letters and numbers. See, now it detects it perfectly. This is frustrating, right? Alphanumeric with a mix of letters and numbers. So now it detected it on the first try. Again, this is a characteristic of the type of prompting that we have, because LLMs are naive and they accept our assumptions as true if we use any type of declarative language, such as, for example, all transactions must start with FT. Even if we say that that statement may not be true, it's still going to consider it true in a dogmatic manner. So we can refine our workflow here to, instead of taking the existing rules and refining those rules, maybe calculating the rules from scratch in every single scenario, and then maybe comparing the new rules with the previous ones and noting down what are the suggested changes, right? That could be something that could work. Either way, let's try the second part now, which is HoneySeek. Based on every single entry in this dataset, please generate suggested access control rules for 3 or 4 different roles in the organization, right? Let's see what it comes up with, right? If this were a real organization, we would have roles and we would suggest the role-based access control for those roles. And for those who are not, familiar with what I'm talking about a specific role having a set of privileges to deal with certain data, right? Maybe, for example, a data scientist would be able to read those data but not change them. Maybe somebody that does not deal with transactions, such as, for example, a marketing person not even having permissions, and so on. But what we're trying to do is to generate those permissions or those access control rules for certain roles. Again, this is very generic, just to show you how it should be done, right? So for example, role, customer role or account holder, these roles would not be even in the organization. They would be external roles, but still they matter, right? If we are the customer, we would have read-only access to recent transactions. We would have a limited view of account balances and transaction history. This checks out, right? It's even talking about password requirements, which is interesting. MFA, for example, to see transactions. This is good. If we were the account holder of a given account, full access to the account balance, limited edit permissions on account details except for the account ID, that should be okay. But you can see how we are giving out these permissions for roles that make sense based on the type of data, right? A generic employee may have access to the transaction data that is relevant to the role. We could even specify here like data scientists, customer support specialists, and so on, but it's possible to do that, right? It's going to detect what data exists and who should have access to those data based on their specific role or the operations that they need to carry out. So as we see, GenAI can be a powerful ally here in terms of generating these rules and policies. But the biggest thing to keep in mind is that GenAI is naive. If you don't give it enough context, or if you don't tell it what is realistic for your organization, it's just going to give you idealistic rules and policies. And with this, we reach the end of our module on data transformation, how to use GenAI for data-related operations when you are actually transforming datasets. As usual, let's take a minute just to recap the content of this module and talk about our key takeaways. We are now at the end of this module on using GenAI for data operations at the data transformation stage. What was our main focus in this module? Well, for example, how to detect schemas in datasets and how to convert those datasets when we actually need to transform data. Or how to both generate metadata for an existing dataset, but also ensure that the metadata remain congruent across new repositories with the same terms and the same definitions. Or how to generate rules dictating the requirements for data validity, as well as policies such as data retention or access control, and also localizing these for specific applications or repositories, both generating the theoretical rules and policies, but also converting them to real-world applications. What are some key takeaways from this module? First, it's crucial to be specific with your criteria and with your fields. Remember, you may have ambiguous transformations, ambiguous metadata definitions, ambiguous rules, and those just result in imprecise generations. the more that you can provide context and talk about specific fields, specific use cases, specific formats, the better that your results are going to be. As in general for any GenAI task, right? But specifically for these use cases. Then, we must provide specific context, especially if the LLM is not fine-tuned on the specific jargon that we use, it doesn't know our definitions, our rules, and so on, we may not be able to consistently use the LLM or to understand its outputs. You have to teach the LLM the specific terms that you use, the specific domain expertise, and so on, either by fine-tuning it or just repeating it in the prompt consistently to make sure that it doesn't forget those terms or change those terms as the context window slides. And also, we must be extra careful with hallucinations and lack of consistency, because repeated generations with a changing context is always a recipe for the outputs not being consistent, right? And that's why you always have to pay even more attention, because if you are generating rules that are going to be applied to the whole enterprise or metadata terms that need to be applied to the whole repositories in the enterprise, then a small change in a term is a fatal flaw when you need absolute consistency. And with this, we close the data transformation module, where we focused on using GenAI for data operations when you are actually transforming datasets. Welcome to this module on real-time integration. This module is going to be a little bit different. Instead of focusing on specific operations, we are going to focus on the pipelines. For example, using GenAI in an automated pipeline to automatically structure incoming data, label them, insert metadata, and store them in a database, for example. Because the dream is to not need humans anymore for certain tasks. Or even if you don't need humans, you can get them involved at certain stages, but you can do other things in an automated manner. So that's what this module is all about. Let's take a look at our lessons and topics. Welcome to this module on real-time integration of data operations performed with generative AI. What is this module going to be about? Well, it's going to be about a general view of the full pipelines with all of the multiple steps and operations that use LLMs in specific to produce results in an automated manner. That is, instead of you needing to pose a question and obtain an answer and then transform the data or do something manually, we want to integrate it in a programmatic manner so that you can use these LLMs in an automated pipeline. Or, for example, examples of automated operations such as fixing incorrect values in a dataset, cleaning the data, transforming those data, and other types of operations that we may use GenAI for. Or, for example, common operations, as well as the common issues and risks for every single one of the data stages that we're going to cover in a pipeline to create or ingest data, to transform data, and so on. What are the usual operations and the usual issues? For this purpose, we are going to have 4 key lessons in this module. The first is going to be about the creation and ingestion stage. That is, automated pipelines to automatically gather data, or standardize data, or cleanse data, or validate those data with data validity rules. Basically, automated pipelines for when you are ingesting or creating data, using GenAI, naturally. Then, our second lesson is going to be about the policy or rule definition stage. That is, an automated pipeline using GenAI to define data validity rules or access control policies or other types of policies, as well as actually enforcing those rules or policies and mapping them with GenAI. Then, lesson number 3 is going to be about the remediation stage. That is, automated pipelines to detect issues, to annotate or enrich data, to reprocess data, and to just log operations with GenAI, naturally. And then, lesson number 4 is going to be about the transformation stage. That is, automated pipelines to detect schemas, to map fields, and to restructure data according to those mappings with generative AI. So basically, as you see, it's applying GenAI in an automated pipeline for each of the stages and the operations that we've previously covered in a manual manner. So as you see, this module is all about taking the tasks that we have discussed so far and grouping them into pipelines so that you can perform these tasks in an automated manner. Let's talk about some GenAI pipelines that you can create at the data creation or ingestion stage. That is, taking certain operations such as structuring data, cleansing them, and validating them, and setting up a pipeline with all of these. Let's take a look. Welcome to this lesson on using GenAI in automated pipelines for their operations at the creation and ingestion stage. At this stage, what do we focus on? Well, on gathering and possibly pre-processing or cleaning the raw data that we are ingesting or creating so that we can prepare those data to be used for any use case that we may have. So what are some common operations that we do here integrating GenAI? Well, for example, gathering data, possibly already structured, or if they are not structured, we structure them with GenAI as well, right? So we may collect news data, for example, which are unstructured, and we also structure them automatically besides gathering them automatically. Or, for example, standardizing the data that we collect, for example, converting all of those data to a JSON format or other output format so that we can use them later. Or, for example, cleansing those data, right? Removing outliers, removing noise, the usual types of cleansing and pre-processing. Or validating data in a preliminary manner if you wish to do so, right? Validating the ranges of specific numbers, validating the schemas, or just validating if that dataset fits our business rules, for example. So what could be a full pipeline or sequence that would leverage GenAI at this stage in terms of the operations in general? Well, we could start by feeding the unstructured data to an LLM for automated schema detection and value range detection. After that, we could automatically standardize or remove the noise or outliers and noting down what were the changes that were actively made by GenAI versus the original dataset. Then formatting the data to the final structure that we need, as well as generating validity rules or business rules if we wish to do so, right? And possibly also generating the metadata, right? Field documentation, sensitivity levels, or documentation rules. So as you see, this is an example of a pipeline for this stage, right? We start by structuring the data, then we standardize those data, then we format them, and then we generate the metadata automatically. So in simple terms, what would this pipeline look like in pseudocode? We would start by obtaining the data from our sources. Then we could use an LLM to detect the schema, returning the schema and the records themselves. Then at the next stage, we could standardize the noise and the outliers in the data, right? So we would use an LLM to return the dataset cleansed of all of those elements. And we could possibly split this into two steps, where the first step is obtaining the answer from the LLM and the second step is parsing that answer, or we could do it in just one pass. It's a matter of transparency and personal preference. Then formatting data to the final format that we want, now that we know the schema, right? So we would take the schema and the dataset and provide those to an LLM and then obtain the final dataset in return. And we can naturally also generate metadata, as we said, right? Taking field descriptions, validity rules, business rules, and so on, right? We would have a function that serves as a wrapper. We provide the dataset, the criteria, and then the LLM actually generates those metadata and returns them in a structured format. Now, what are some limitations and risks that we may face at this specific stage? Well, one is the speed of data processing itself, right? Which may not be very high because, especially for high volumes of data, we're going to need to wait for one or multiple LLM answers when the data would otherwise just be saved or inserted, right? If you are creating data or ingesting data at a high pace, putting an LLM in the middle of that process, yes, it does help with detecting the schema and other operations, but it is going to slow you down substantially, especially if you want the high level of transparency and you have multiple passes, right? One LLM answer to obtain the schema, one LLM answer to cleanse the data, and so on. The more that you do this, the slower it becomes. Then, GenAI can create errors or format data in the wrong format, right? Hallucinations, but just in the context of data operations with GenAI, right? So especially if you don't have a human staff overlooking the LLM outputs, if in the middle of 25 datasets that you process, for example, one has completely wrong values and nobody bothers to check to a very deep level, you are never going to know this, right? So you may find out later or never. As we mentioned before, this is a trade-off because the more LLM answers that you use for every single step, the more transparency that you have, but it's going to slow you down and eat up a lot of resources. You can also do this with few answers and less resources, but you're not going to have that transparency, right? So you want to define what is the risk level or the risk tolerance that you have in this process. And finally, notice that using GenAI may not be scalable at all for your use case because, as we mentioned, especially if you're dealing with big data and you're constantly generating LLM answers in near real time or real time, and the pipeline can be very intense, or it may just not happen at all, right? So you may end up not performing this pipeline for certain types of data, right? Maybe you only run the LLM answers for certain types of data that are acquired at a lower pace. Or you may just decide to up the resources, the actual computational resources, such as hardware, that you actually have to make this scalable, right? Again, it's another trade-off that you have to consider. So in this module, we are going to tackle things in a little bit of a different manner, right? Because it's about pipelines. So what I decided to do was to create a small script, not exactly a small script, but it's a script that processes a set of files and that performs some operation. So what we do is, I don't want to bore you with all of the technical details, but essentially we take the input folder and output folder and we're going to process all of the different files based on our use case. So for this first lesson on the creation and ingestion stage where we want to format the data and maybe clean them, we are going to have an inputs folder where I'm going to place files and then it's going to process them in real time and output the corrected files or the corrected data sets in this case with the help of an LLM. And what we're going to do is we are going to have this prompt file here, which I have already configured, but we can say something like, please convert the attached news file to a JSON format, right? Because in this example, what we're going to do is we are going to have a set of unstructured news files, right? Let's say that we are obtaining them from somewhere, maybe scraping them ethically, or maybe obtaining them from some source in an unstructured manner, right? And what we want to do is we want to standardize the structure of these news files and output them as JSON, right? Essentially what we're doing here is we have a very short cycle, a very simple script where what we do is we establish the connection to the client, in this case, the DeepSeek model 7B version with Obama. And then we have some sort of loop where we wait, for example, 10 seconds. Then we run through all of the files. Maybe we overwrite them or not if they have already been converted. But basically, it serves as kind of a watchdog that checks what are the new files that exist in terms of those news files. And then it processes every single one of those according to a prompt that is going to be in this prompt file, right? And because we are running this as one LLM answer for every single news file, naturally the prompt says, please convert this specific attached news file to a JSON format. So what we are going to try to do is to run this pipeline processing script. And we already see that it's getting a failure for some sort of file. Maybe there's a hidden file here, but let's ignore it. And let's just drop one of these files here, and it should process the text file, right, and generate the appropriate JSON based on our specific prompt. I don't know how long it takes between processing the different files, but it should treat it, and then it should output it here in this specific folder. Maybe I should have placed the shorter interval so that we don't have to wait so much between the processing steps. Okay, it's finally processing the file. And what is the output here? Okay, here is the structured JSON format, and there is a JSON, right? So we can see that it did convert the news file to a JSON file. So Amazon opens first, cashier of store. It is pretty much the same, right? But we can see that we didn't specify any field, so it's kind of converting this in a freestyle manner, okay? And I think that I have the overwrite mode activated. So while it keeps running, it's replacing this file with a newer version. So here's what I'm going to do, okay? I am going to, first of all, pause the script. I am going to turn the overwrite mode to false. Or actually, let's keep it true. Let's shorten the scan interval, and let's change the prompt as usual to say, okay, the attached news file to JSON format, please output just the JSON and nothing else in your answer. And we can say something like, please include the essential fields, headline, date as year, month, day, and summary containing the news content, right? So here's the thing. I don't even think that we did have to close the script because I think that it's obtaining the specific prompt in every single instance, but still, we are going to do it like that. And let me just insert two other files so that we can see whether it's going to process these two and whether the format is going to be the format that we want or not, right? So it's not exactly what we want because it says results instead of just saying headline, date, summary. And there is this kind of preceding and trailing commas, which is not exactly what we want, but we could include another step in this processing file to actually convert this. Okay, so we are getting an error. I'm unable to proceed. There is no attached news file for me to convert into JSON. Okay, so that is weird because it converted this literal file a couple of seconds ago, but on the new pass, it's not doing it, right? So what we have to do here is, okay, we can already see that it has headline, date, summary. And here's the thing. I'm just showing the generic script and how it would work, right? What you could do here, if you're up for it, is add some sort of validation step. Okay, now it's validating the news file, headline, date, summary. Okay, so what we could do here is we could add maybe an additional step that trims the preceding text and the trailing text from this JSON, or even instead of just having one pass, we could do something like modifying the code and saying, hey, in this outputs not the output file path, but the final answer. We try to parse the final answer as a JSON file. And if we do not find the fields that we want, such as headline, date, or summary, we just repeat the same exact answer in the LLM until we get what we want. But you can see the basic flow of it here, right? We are taking these unstructured news files, we are dumping them into this folder, and the script is just running like a watchdog, and it's converting them as they go. And this could be done with, for example, new entries in an SQL database or unstructured databases or anything. But that's the principle, right? It's just a pipeline that is performing a set of operations, and we are adjusting this prompt in order to transform the input data in some way and output it to a different directory. That's how we would do it, for example. So as you see, this is a pipeline that you can create, but it can introduce certain challenges, such as, for example, less speed, less scalability, or introducing errors. Let's talk about some pipelines with GenAI operations at the rule or policy creation stage. That is, we're going to take certain operations such as automatically creating data validity rules, policies, and possibly even enforcing those on existing datasets. Let's take a look at how this would be set up. Welcome to this lesson on data pipelines in an automated manner with generative AI, specifically when you are defining data validity rules or other policies for a dataset. Let's take a look. At this stage, as we covered, what we want to do is define the rules and the policies and define the access to or validate the governance of the data. In other words, we are going to create various different rules or policies that may apply to different scopes: access control, security, data retention, and so on. We define the ones that we want to apply, but usually when we have a data set and information on the formats and the use case that we have, we can already start generating these. So usually it's going to be connected to the data creation stage or soon after that, after the data are documented. What are some common operations, including GenAI, that we have at this stage? Well, we can start by defining business rules or data validity rules based on the data. For example, if all of the values for a specific field are between 1 and 50, then maybe we should make that a formal rule for data validity. All values must be between 1 and 50 for this specific feature. Or defining access control policies in terms of data privacy based on the content, right? For example, this dataset has personally identifiable information within it, so the dataset has been tagged as sensitive data. Or actually enforcing those validity rules or mapping them to various code bases as we covered, right? So automatically flagging data that doesn't comply with the validity rules or excluding those data if they're invalid, for example, or marking them for remediation, flagging them, and excluding them from the actual pipeline until they have been fixed. Or, for example, just translating a policy to specific apps or code bases. Again, if we had the example of retaining data for 30 days, how does that look like for every single one of our databases, data warehouses, applications that create data or delete data, and so on? So what is an example of a full pipeline or sequence already leveraging GenAI in terms of the steps? Well, the first step could be defining the actual data validity rules or business rules, either based on incoming data or internal data governance work. In other words, if we just receive a data set and we have to define the data validity rules, or maybe we have a data set that has been there for a long time, but somebody finally decided that it's time to define the metadata and the data validity rules for that data set. Then we could create policies based on those rules, right? For example, now that we know that this specific number has to be between 1 and 50, or that a specific feature must have certain values, now we can define other things, right? Access control, privacy or security controls based on the sensitivity level of the data, data retention policies, regulation, and so on, right? What are the rules and the policies that come from that data set being documented? Then another step could be to validate new data based on those rules. For example, if we define a data validity rule that an instance of the customer entity must have an ID and a valid address, then now anytime that we acquire or ingest new customer data, it has to obey those rules. And maybe even refining the rules that we already have for new data sets based on the value ranges, right? For example, maybe we find out that a certain value is not between 1 and 50, it's between 1 and 60, because we didn't take into account the outliers, right? Maybe the initial data set did not tell us that, but doing profiling on other data sets helps us refine that rule, because we didn't face that specific value before, but now we've expanded our horizons, if you will, and now we have to expand the data validity rule as well. Just an example. And then also mapping those to code bases, right? Now that we have defined all data validity rules and all appropriate policies, the general ones, how do we translate them? Again, our example, if we have a data retention rule, or even if we have a data sensitivity rule limiting access control to certain users, how does that translate to the specific users of this app, the specific database administrators of this database, the specific business users with access to this specific interface, and so on? how do we translate a generic rule or policy to the specific applications and databases that we have? So how would this look like in pseudocode? Well, we would start by defining the validity rules or the business rules. For example, we use a function that takes the LLM and parses the rules for a specific dataset and returns those rules and the dataset. Maybe it works just for the data validity rules or the business rules. It's up to us. Then we generate the policies based on those rules. Maybe we have a function that generates the policies based on the dataset, the LLM instance, the validity rules, and the existing policies, and then extrapolates the new policies for that dataset. It may take into account sensitivity, privacy and security, regulation, or whatever scope we may have here, right? We may even skip the policies altogether and just do the data validity rules. It depends on your specific use case and how much effort you want to put into creating this pipeline naturally. Then the step that would come afterwards is validating incoming data based on the validity rules, right? So we would have a function that validates new datasets based on the specific rules that we have. And do notice that here, just for the sake of illustration, I'm including this as a step in our pipeline, but maybe it wouldn't work exactly like this. Maybe we would save the rule as a text file, for example, or a specific entry somewhere. And then there's another pipeline that when data are ingested, runs those data by that specific rule to validate them. And we are just updating the rule that is going to be used somewhere else. But for the sake of illustration, I'm including all of these steps as sequential steps in the pipeline. And maybe based on those results of finding invalid data or other inconsistencies, we would send out an alert to the data management team, or maybe even add a task to their queue or the pipeline if we have integration with the help desk software or whatever the ticketing software is, right? And then mapping the general policies that we've created above to specific applications or software code, right? So if we have a list of applications or code bases, then we would simply take the LLM instance and the application code and adapt the policy to that code. In this case, I did not even use the policy as an argument to this pseudo function, but I should have, right? It should take into account the LLM, the target code base, and the specific policy that we want to convert, right? For example, a data retention policy, or maybe we are applying all of them here. And possibly, depending on our workflow, we would create an alert for that team, right? For example, if you have a new data retention policy that is going to be integrated into the organization, then maybe you convert that specific policy to changes in the specific application's code and you push out an alert to the specific developer team, right? And again, I'm using this as a very generic pipeline just to illustrate the workflow. But maybe in a big organization, you would have separate teams, right? Maybe the data governance team just generates the raw policies and puts them in some specific sort of storage or repository. And then maybe the specific application team goes to that repository, fetches the policy, uses an LLM to convert it to specific changes in the application code, and so on. So this, again, is just a generic process to illustrate how this could be integrated into a workflow. And as usual, we do have risks and limitations here. Surprise, surprise. So one of them is that the rules may be overly complex for an LLM, right? Especially if we have business rules or counterintuitive rules that are not very well explained and that cannot be easily deduced. Maybe the LLM can't reach those conclusions, or maybe it's going to come up with something else, right? So these may require including additional content for context, such as using RAG with documents or manual review. Right? For example, if you are asking an LLM to interpret the consequences of a specific piece of regulation for this specific data set, but you haven't mentioned that there's a specific use case within that regulation. For example, if we're talking about the AI Act and the specific use case that you have, how you impact people, whether you impact in financial terms, in terms of their career, and so on. And if you don't provide a specific use case, then the LLM is not going to be able to provide a clear rule or a clear policy for that specific data set. The more context that you provide about specifically how regulation or anything else impacts you, the better that the LLM is going to do its job, right? Then the recommendations may be inconsistent, right? If you are running multiple datasets for the same instance of an LLM in the context it generates, you may have a case where the first and the last answers may vary greatly, right? Remember, an LLM has a specific context window. Certain meanings of certain words may start to change, or it may start to imitate the use cases that you have done at the beginning of the conversation, even if the latter use cases are supposed to be different, and so on. Remember, as the context of an LLM changes, what it does may change as well. And then there are certain things, such as those freak accidents, where, for example, if you're using a policy with 3 points, but then suddenly it makes one policy with 4 points in an answer, now it starts doing all policy answers with 4 points, right? So either due to the quantity of answers or just because there's a freak accident in the context, it may degenerate and the answers that you get may start to change. And then the generated rules by the LLM may diverge from the current ones, right? In order to keep the new generations consistent, the context has to be pristine. So either you include that information and repeat it every single time, or you include it with RAG, or you include it manually for every single generation, right? But either way, if the context window starts to slide as you ask more and more questions to the LLM, then certain meanings of certain words may change. And what an LLM does is, when it doesn't know a specific meaning of something anymore, it doesn't tell you that, it guesses, right? But when it starts guessing something, you start to have problems. Because, for example, if it forgets what revenue means in your specific company and it just makes a general guess, you are going to have answers which are wrong, but they seem very, very true, right? They're probably true, but they are not actually true. So the LLM, when it forgets specific aspects of your unique jargon or unique documentation, it's going to make up something that would probably be true according to all of the other context, but it may not be exactly what it means, right? So do take into account that the context may degenerate, and then you get these consequences. So in this lesson, our example is going to be how to generate the data validity rules or the policies related to, for example, data sensitivity or data retention in an automated manner. So we are going to come here to our trusted script, and I have already adjusted the folders to take this new folder that contains data sets of customers, okay? And what we want to do here is based on the information that is contained in these customers, in the data formats and the values, to kind of extrapolate the data validity rules and the policies. In this case, I'm not going to focus that much on the output format because usually the policies or the data validity rules, they're human readable, right? Maybe we are trying to generate a policy in a structured manner, such as for Microsoft Azure, which is going to be a structured JSON format. But in this case, I'm not thinking about that, right? So this is going to be a little bit less strict than the previous one. And what I'm going to do here is just say, remember that we are going to process one file at a time, right? So for this data set, please take a look at the attached data set and generate data validity rules for each of the fields, right? We are going to start with a simple prompt, and then we are going to evolve it as the program hopefully works, right? So we are going to have input here. Let me just restart this so that we don't have to wait for the next cycle. And it should process the data set and output the data validity rules. As usual, we're going to start out with a simple example and then slowly ramp it up, right? Do we want specific things in terms of the data validity? Do we necessarily want a range for the data? Do we want the expected values? Do we want the average value or the median value? We'll take a look at that later, right? But right now, I'm just letting it run and see what are the raw outputs, right? We're going to have to wait a little bit. And it's here. Okay, so what do we have here? To ensure the validity of the data set, we need to define rules, customer ID, first name, last name. Let me just close this before it overwrites those validity rules. Okay, so this actually seems very reasonable, right? We didn't take a look at the original data set, but if we take a look at it very quickly, okay, so we have a customer ID, which is naturally an integer number, or actually it isn't. It's alphanumeric with EC followed by a hyphen, then 4 digits, John Smith, first name, last name, email, phone number, date of birth. So naturally, depending on your specific data structures and data sets, you may have these very complex rules. But right now, I'm just thinking, okay, is this right? Yes, it follows the pattern EC with a dash and then with 4 digits. This is actually working a lot better than it did in the simple example where we were just calculating the schema, right? Now that we're running this in an automated manner, it gets it right at the first try. Well, that is life, I guess. So first name, non-empty string with alphabetic characters, same for last name. The email is a valid email address. So naturally, you are going to find out that certain formats, the LLM already knows about them. So it's going to tell you exactly how they should work, right? If you have an email, you don't even need to know what is your specific email format because all email formats are the same. Okay, so I'm going to consider this acceptable. And what I'm going to do is I'm going to change the prompt here to say, generate data validity rules for each of the fields, including value ranges if possible. And now, also for each field, please attribute it a data sensitivity level from low to high. Also, if the field contains PII, personally identifiable information, please flag that, okay? And here is the data set, right? Because the data set is going to be attached with every single prompt. So we are going to run this again, and let me add another data set to this cycle, this processing cycle. So we can see that the second data set is not that different from the first one. It has an account number, annual income, credit score. So this is interesting, right? I'm interested in seeing what it's going to consider personally identifiable information versus not, right? So we have financial data, we have IDs, we have emails, we have phone numbers. So I'm eager to see what type of conclusion we get from this processing. You also notice that naturally, if you have in your own organization a list of rules or a list of parameters or a glossary, if you define on a very granular level, what is PII, for example, versus what isn't, or what is the default data sensitivity level for the specific type of field, all of that can be reflected on this script, right? Again, we are starting with a very basic example, and then we'll slowly ramp it up and kind of take this LLM to its limit, which it's a small LLM, so the limit is not that high. I really wanted it to process the second file right away, but for some reason, it's taking some time. So I'm wondering if there is an interval between processing the files, but it seems like there isn't, which makes this very weird, okay? Because it's processing the file, and the processing of the file doesn't have any wait time. It just waits after processing all of the files, which makes it weird. It's not even detecting the second one. Okay, so something is wrong here. We'll fix the script for sure. But at the end of the day, let's see if it's doing what we want, right? The problem is with the cycle, not with the LLM itself, which is good. Okay, below is an analysis of the data validity rules. Okay, so customer ID, is it personally identifiable information? Yes, first name, last name, email, phone number, date of birth. So all of these are PII, which is actually reasonable, right? Registration date, the purchase count is not PII, the total spent is not PII, the preferred payment method is PII. We can see that it's making some common sense. It's drawing some common sense conclusions here, right? So the preferred payment method is naturally has a high level of sensitivities, as well as the registration date or date of birth, right? The purchase count is an aggregation of purchases, so it's not that high. Do we even have a low value here? No, the state. Okay, so the state in terms of the actual state in geographical terms, it's medium, while the city is high and the zip code is high, right? So all of this does make sense, right? Because it's flagging types of information which are highly personal as having a high level, while the others have a medium level, right? And again, you could insert your own demands in terms of the sensitivity levels that you may have, or PII flags, or any other type of taxonomy. You can even do it by attaching documents with REG that we're going to take a look at in the next module. But that's something that helps prevent hallucinations and makes this work in a better manner. But for now, you see how this is working, right? It's processing the files, or the file in this case, because there's something wrong with the cycle, but we'll take a look at that later. But it's processing the files and it's outputting the data validity rules for each of these files, right? And again, we can tailor these rules, we can ask for more things. Do you want to maybe include access control policies now or data retention policies? And this is how it's generally done, right? But again, remember that you don't want to do many things at the same time, because otherwise the attention span of the LLM may be, spread too thin, and then you end up with something that doesn't work, right? Because it's doing a little bit of every task, but it's not doing any task fully. I guess that we could even edit it in the actual script in the future. Instead of having one response for one prompt, we could have two prompt files. For example, one for data validity rules and another one for the sensitivity levels, and just run the LLM twice, right? It's one of those things that may work. If you are willing to do two passes instead of one pass, you know that the results are going to be better because you're doing one thing at a time and you're not spreading that attention mechanism too thin. So as we see, we can use GenAI for this type of pipeline as well, but we do have certain challenges that may pop up, such as the new recommendations being inconsistent or enforcement being ambiguous because we don't provide enough contextual information for it to be specific. Let's talk about some pipelines with GenAI at the data remediation stage. This is going to be the more typical pipeline, if you will, right? We can use GenAI to automatically profile data, find out what are the errors, either push those errors to a human or fix those errors ourselves, maybe even reprocess the dataset after we have fixed the errors, and more. Let's take a look at how to set up this type of pipeline. Welcome to this lesson on creating automated pipelines, including GenAI for data operations at the specific remediation stage. At this stage, what are we doing, right? We are detecting and correcting errors in the data, the usual activities of the data management team. At the end of the day, we want to increase the quality of those data and ensure that they are valid, complying with the data validity rules. As simple as that. We have data that have low quality and we want to increase their quality. So what are common operations that we do at this stage, already including the use cases for generative AI? Well, automatically detecting issues using GenAI, especially business rule issues, for example, such as using an LLM besides profiling the data to actually scan for issues in the data, which may not have to do with the data themselves, but the logic, right? A very basic example would be for every instance of a customer entity, for example, having an associated tax information instance of an entity as well, right? And GenAI can help you automatically detecting not just problems with the data, but problems in the relationships among the different entities. Or, for example, annotating and enriching the data, right? For example, running a dataset through an LLM with RAG to append relevant information. If you want, for example, to obtain customer insights, you could take a dataset of customers that you have and embed the location in every single one of these. If they don't already have the location, you can take the specific geography that may exist in another dataset, and you can use an LLM to run the customer dataset and append the location to every single one of those customers. For example, in this case, we're not necessarily fixing errors, but we are increasing the quality of the data by adding additional information here. Or, for example, just reprocessing the data, right? Taking data that were rejected, fixing those data, and then pushing them back into the pipeline, right? And now those data are going to be accepted. If you have an LLM that you trust that can do this with efficiency, you could have almost an automated pipeline where you ingest data. Those data don't pass the data validity rules. They are pushed to another LLM, which is going to fix those data by either filling in missing values or guessing those values based on specific criteria, and then push those data right back into the ingestion pipeline, right? You could do this with the data management team with a manual step, or if you trust your LLM enough, or if you have a specific LLM just for remediation that has been fine-tuned, then you can do this in a fully automated manner. And then finally, also logging the efforts in terms of remediation. This is more of an administrative task, but it's still important, and GenAI can help, right? Automatically tracking which data were changed, what were the dates and times of the remediation initiatives, generating metadata, and generating logs in general, right? So taking care of the grunt work, if you will, associated with remediation tasks. What would a full pipeline or sequence leveraging GenAI look like here? Well, we could start by actually detecting the errors, right? Either automatically scanning for incoming data based on a schema or running manual scans on datasets that you may already have. But either way, you find out about new errors to add to the remediation pipeline, if you will. Then we correct those errors using an LLM, or we push those errors to a data management queue so that they can take care of them in a human manner, right? So either we replace or remove incongruent values, we remove duplicates, we change formats of the data, the usual types of remediation, if you will, or we just suggest those to the data management team, right? Even if the LLM doesn't fix the data itself, it can already help a lot by just suggesting the remediations. For example, taking an incoming data set and flagging the customers as not having a location for every single entry. And then when the data management team sees that specific item in the queue, they see, oh, this data set doesn't have locations for any of the customers. We just have to fix that in some way, right? So even if the LLM doesn't actively fix the issues, it can still help the data management team by prioritizing those issues or just by filling in more information about the tasks to be done. Then a third step could be pushing that for review. That is, whether the LLM actually fixes that dataset or doesn't, it then pushes out an alert to the data management team saying, hey, either you have to fix this dataset or I have fixed this dataset, please review the changes. So pushing a ticket to the data management team to actively review something, if you will, or just to actually perform the task with some suggestions. And finally, also suggesting changes for the future if you want to take care of that, right? So for example, for planned future data migrations or transformation projects, LLMs can already note down what would need to be changed. For example, if you have a master data management project that is going to happen in the future, then the LLM can already start to plan, hey, maybe these specific fields will need to be changed, or do take into account that you are going to need to merge this specific field. But as for now, these are just suggestions of what could change in the future. So in pseudocode, how would this pipeline look like? Well, we start by detecting and correcting errors in the data and pushing out an alert to the data management team to review it after it's done. So for every data set that we would have in our remediation queue, we would first obtain a list of the errors and the possible fixes for those errors by profiling the dataset. Then, for every single one of those errors that were detected, maybe we apply a specific confidence level. For example, if the LLM is not more than 85% sure that this really is an error, let's ignore it. But otherwise, let's actually remediate that error for this specific dataset. Or instead of having this for loop, you could actually do it all at once. if the data set is small and you trust the LLM to take care of everything at once, or you could take care of every single one of them as one pass. It's your choice. And then after every error is remediated, we would send a review request to the data management team with the specifics of that error. And again, here I'm including the review request for every single error fixed, but maybe we could do it at the dataset level after all errors for that dataset have been fixed. Again, it's up to you. Do you want more granularity, or you want to group all of those tasks as one thing, right? I'm just illustrating the workflow. And if the confidence level is not high enough, then you would queue the remediation project for the humans. In other words, if the LLM thinks that there is an error here, but it's not entirely sure, why not push it to the data management team just so that they can take a human look at it and gauge whether it's actually an error or whether it was just an LLM glitch. And then we can also suggest recommendations for future migrations or transformations. What to take into account for this specific dataset for the future tasks that we have planned. So for every dataset in our datasets, we would generate recommendations in terms of migration or transformation with an LLM as well, with a simple function. Or possibly generating recommendations for changes in the schema of that dataset based on our future. For example, if we know that we are going to need to integrate a legacy system with our current database, what are some suggestions in terms of schema changes for that specific legacy dataset, for example? And then again, you would send a report to the data management team. We're getting a lot of reports today, or for any other team that would be responsible for these future plans or migrations. Or you may not even send out a report, but store these suggestions as metadata for a specific dataset, or send them to a specific team that is going to be responsible for that project in the future, and so on. It's up to you, but this is the general workflow. Now, naturally, as for any other type of activity, we do have limitations and problems with using GenAI in an automated way. One would be the LLM not fixing the errors or even causing new errors, or maybe doing both, right? Not fixing the errors that you asked it to fix and even introducing new errors or new noise. So those are two possible problems, I guess, that could both occur. The hallucinations by an LLM take a specific shape, which is wrong suggestions of what to fix, or actually not executing the fixing of the data, if you will, right? So they may not fix the data, or they may introduce noise, right? So manual review is recommended. This is why in the pseudocode, I was always sending out an alert to the data management team, because you don't want an LLM that is automatically fixing something, and that's it, period, and nobody takes a look at the work that it has done. Maybe if you fine-tune an LLM on a specific type of data with enough context and enough specific jargon and specific terminology that you use, maybe it would be more acceptable, but even then, you should do multiple passes for multiple types of errors and always have human oversight over the LLM outputs. Because otherwise, you could have a dataset that is completely changed or corrupted by the so-called fixes, which are not fixes at all. Then, remediation may be too coarse for certain data. That is, for highly sensitive, personally identifiable information, such as health information, you can't just blindly remediate a dataset with GenAI, right? In our example, if you have a list of 50 customers that don't have a location for every single one of those 50, you're not going to use GenAI to automatically fill that location based on documents that you may have, right? If that specific dataset is important enough or sensitive enough, you want to have somebody actually going through each entry, finding out what is the value that is missing, or finding out how to estimate it with a lot of accuracy and filling it, right? It depends on the use case and the sensitivity of the data, but sometimes just blindly fixing a dataset with GenAI may not be acceptable. Or in other cases, it may be completely acceptable, right? If you have open data or public data, or if you're generating articles or something else based on other documentation, again, it depends on the use case and the data which are involved and their characteristics. And finally, we may have a lack of context, right? In certain cases, additional data are needed to fix a specific field, right? In our example, if you have a list of customers without the location, where are you going to obtain the location from? Maybe the billing address from past purchases? There has to be a source of information for what you are filling, right? And GenAI works like that. If you're using GenAI to fill values without providing the specific context for those values, it's going to guess. And the guess that an LLM makes, it's going to be what is probably true, but especially if the data are counterintuitive, or if the LLM doesn't have enough context, then what is probably true may be very far from the actual truth, right? So do notice that, as for many other operations, the less context that GenAI has, the worse the results you're going to get. So as for many other operations that we have covered, the less context that the GenAI model has, the worse the results are going to be. But in a specific case, when you want to fix data, maybe you don't want to have fixes without context because the results are just going to be bogus. In this lesson, we are going to remedy data, which is definitely one of the most complex use cases because naturally we want to keep the original data, but at the same time, we may want to change the format of something, or we may want to standardize something or cleanse noise or actually fill values which are missing. But we are going to try and process that in our trusted automated pipeline. So what we have here for this lesson is a list of product data sets, right? They have fields like product ID, SKU. You can see that they don't have the same exact field. So I did this on purpose so that we would have different data sets so that it can predict anything, right? And we can see that in certain cases, they start with an uppercase letter or maybe they're lowercase, but we're going to try and fill missing values if we do find those values. And we are going to try at the same time to standardize things like names. Okay, so this should be a fun lesson, I guess, hopefully. So in our prompt, we are just going to say something like, "Hey DeepSeek, please fill in the incomplete values in this data set." And what we're going to do is we are going to try to include that confidence score in terms of how confident it is that it is filling in the missing value using the context that it has, right? How much is it trusting the completion of that incomplete value? So please also include a confidence score field. I'm going to call it a completeness confidence score field, which represents how confident you are in the value field. Please output the corrected data set and nothing else. Please do not change any at the original data, just add the incomplete values. So for now, we're just focusing on completing these values. Then we'll maybe tackle also the standardizing of the noise and everything else. Okay, so we are going to run this and we are going to drop here 2 data sets at once. And let's see if it processes it well. So what I'm going to do is I'm going to open this. By the way, I didn't mention this, but I put all of the data sets in here as text files because they're just easy to process this way, right? The focus of this lesson is how to process data with an LLM and output data. The focus is not that much on, how to extract the data, how to get it in an actionable format, right? So you could have this in a different format, CSV, JSON, and export from an SQL database, whatever it is. But I place them here as text because I think it's the simplest manner to work with the data, right? The focus is not on how to extract the data or how to work with them. The focus right here is just taking the data and using the LLM to transform the data in some way. Okay. So I think it's already processing a file and overriding it. In this case, it's actually processing both files. So I don't know why it did not do that in the previous version, but let's see what answers we get. Okay, so we are getting some problems that we had already tackled before, right? Which is, for example, they're divided by pipes instead of just being a CSV format, but that's on me because I did not specify that. And we still have text besides the data set, right? Same thing here. Here's a corrected data set, now includes all specified information. You can also see that it's not adding the confidence score as a column in the actual data set. It's adding it as a separate value on the outside of the data set, if you will. Okay, how do we fix this? By editing the prompt, right? Include a field which represents how confident. I'm going to call it a column. So this should be an additional column in the data set side by side with the others. Please do not change any of the original data, just add incomplete values. Please do not output any text except for the data set and just the data set. Again, I'm going to use the justification of what I want to do with it because it sometimes makes it easier for the LLM to understand. I want to be able to copy paste your answer onto an Excel. So just the data set as output, please. Again, we can see that when we want to prompt for something, the stronger that we prompt for it, the higher the chances that it's actually going to be in the final output, right? It's very similar to if you're generating a picture with a generative image AI. If you say, I want it to be a man with black hair, if you just say black hair, then the person that is generated may have black hair. But if you use black hair with a very high weight, then that person is definitely going to have black hair in that generation, right? We're doing something like that here. The more that you mention something in the prompt, the higher the chances that it's going to make its way to the final output, right? Correct the data set as CSV, delimited by commas. I'm being very explicit here about the results that I want to make sure that it really does, do it, I guess. So we're just going to wait for it to process both of these files and then take a look at whether they are acceptable or not, right? And no reason why it shouldn't be acceptable, but still, we are curious. So we are just filling in the incomplete values for now. And then we are going to try and tackle standardizing names and fields and such. Again, it may not be a very good idea to do everything in one pass, but what we can do is in the future, this is just an example of a script, right? You can have your own pipeline and you could have two passes of the LLM. One of them to actually fill in the incomplete values, and then another one that takes in the data set with the complete values and standardizes the text too, or with a reverse order. But do take into account that the longer the number of LLM answers that you are chaining, the higher the chances that something is going wrong, right? Because it's hard enough to detect errors in one LLM answer, but if you take one LLM answer and you use it as input for another LLM answer, then the data could have been tampered with, without intention by the LLM at any of these stages. So the more that you chain these together, the higher the chances that something could go wrong and you may not even notice it. Okay, so this is still not ideal because we have something that says, here's the correct data set, and then you have the data set here, okay? And then here's your data set with the completeness confidence score added. So it's still not ideal because we're still getting this, but we already have some clues here, right? Which is, for example, when it's including a data set, I'm guessing that these three quotes are some sort of symbol. For example, if it were conversing with you on an interface, this would be some sort of delimiter for code, for example, or for showing text as a code font or something like that. So we could actually strip the answer by this first part and just get the data set between these two delimiters, right? That is something that we could do. There's a lot that we could do here to try and parse this in a better manner. Or we can just use the brute force method, which is get the answer, see if you can parse the CSV out of it. If you don't, just repeat the LLM answer. If you have enough processing power and you're willing to do that, that could occur as well, right? So we have the confidence score here. We can see that at least it added it here as well, right? So confidence score, 85%, 95%, 75%, 85%, 85%, right? I didn't even focus on what were the values that we did not have at the beginning. So I'm trusting that this is filling the values, but naturally in a scenario with production data or with important data, you would naturally take a look at every single one of these fields and make sure that this is really happening. I'm trying to condense the whole experience in a 5-minute practical video, but you would spend days on this, just tinkering with every single data. It can even be the case that if the data are important enough, you just fix one single field at a time, or you chop up the data set and you hide certain fields which are not relevant, right? For example, if you're trying to fill in a missing transaction value, then maybe the product name is relevant because it indicates the type of product, but maybe, for example, the user ID doesn't make sense or something like that, right? So there's a combination of prompting harder and doing less things at the same time and just being willing to spend processing power on subsequent versions of the same answer, where if you combine all of those factors, it tends to increase your results. There is no one silver bullet here, but a combination of these will naturally help, right? Okay, so let's do this now. Let's try and standardize and correct names which may be wrong, right? So we have here our very strong directive to only output the dataset. Let's do the following. Please also correct incorrect words and capitalize them so that the text is standardized and has no noise. Why am I hesitating here? Because I'm afraid that it's going to try and standardize the number fields as well, and that there is a lot that may be wrong here, right? I remember that we had the words, which was, I think, Bluetooth, that was written as Bluetooth. We just want O, and we want to correct that, but we don't want it to try and correct everything at once, because that could be a disaster. So what we could even do here is see, where did it say Bluetooth? Okay, here, Bluetooth speaker. So this is the product name. So what I'm going to do is I'm going to say, please correct incorrect words and capitalize them in product names, right? So I'm specifying the column. What we may end up doing is we may have a list of fields where we know that there's problems with the words, but we know that those problems only occur in those fields. So we may tell the LLM to only fix those fields too. Either way, let's see how it works or whether it works. I trust that it's going to achieve some sort of combination of reasonable results in terms of filling the values and also fixing the incorrect words in the text. But as we said, we're trying to do two operations with the same answer, which can be dangerous. Ideally, you want to have a very strong prompt, split this into 2 passes, and have some sort of manual vetting of every single one of those passes as well, right? Again, I'm trying to summarize this in a 5-minute video with a very small model that was not fine-tuned on any sort of data activity or these data. So this is the absolute worst case scenario, but it's good enough to illustrate how this would be done. Okay. In this case, we actually got the original data set and then a second version of the data set, right? So I think that it's literally just outputting, the data set twice, one with the confidence score and the other without the confidence score. And we can also see here that in the past, the confidence score was a decimal. So it was 0.9, for example. Now it's a percentage. That is fine because we may be able to parse it. That's not a deal breaker. But the fact that it output the data set twice, that is a deal breaker, right? So we would repeat it here, or we would try to do one of the 2 operations at once. See, when we're trying to do 2 things at the same time, or even 3 things, it's going to split the attention across these, and it may end up not doing any of them right? But we did get Bluetooth speaker, for example, right? Smart TV, laptop computer, digital camera. So we see that all of the names are okay. And in this case, well, it did output it as a CSV. It's not the only thing that it's in the answer, but the completeness confidence score is apart from the basic data set, right? So this is one of those situations where we may end up just, having to have multiple answers. And by the way, when I mean multiple answers, you don't necessarily need to start the context from scratch and repeat this. You could have a situation where you get the initial answer, you try to parse it, and if it's not a data set, you add a new reply to the same conversation with the same context saying, hey, good answer, but please output just the data set, right? So they don't need to be 2 initial answers, 2 different versions of the same query. They could be one answer and then one subsequent answer in that conversation to refine the answer and then output it as the data set, right? So that could work. But you can pretty much see what we're doing here, right? We are taking a set of inputs and we have a very basic script that takes each of the input files, fixes those inconsistencies in the data or in the text, and also tries to fill in the missing values and outputs the corrected data sets. And as usual, you could do a lot with this, right? You could push these to a data management team saying, hey, here's the original file, here's the fixed file, please gauge whether this is acceptable or not. Or you could actually already insert them in a specific data set, but have a flag that says that these were AI generated or AI edited in a way. There's a lot that you could do here, but this is the general process, right? The general pipeline. So as we see, GenAI can also help you generate this type of pipeline, but it is important to understand that all of the errors with these operations that could occur due to GenAI can occur here as well. It may introduce new errors, it may not fix errors, it may be ambiguous in how it fixes the errors in the data, and more. Let's talk a little bit about how to use GenAI for pipelines at the data transformation stage. This one is also going to be a little bit more of a typical use case, if you will. We are going to find out what is the source and target schema, map the fields, and actually transform the data set. Very simple. Let's take a look at how to set it up. Welcome to this lesson on how to use GenAI in an automated pipeline for data operations at the transformation stage when you are transforming a data set, for example, changing its schema and the field mappings. At this stage, as we said, we are transforming the data in some way, either to insert them in a different database or integrate with other data sources, or for other possible use cases, such as converting historical data to grouped statistics or aggregated statistics of some sort, right? But either way, we need to transform a dataset to a different schema, and we want to transform the fields with some specific criteria or direction. So, what are some common operations that we can perform in an automated manner with GenAI at this stage? One is detecting the actual schemas in datasets, right? Again, detecting the data types, the formats, and other properties if we don't know them already. We may need to transform a dataset whose schema we already know, or a dataset that has just come in and we have no idea what it contains, right? Both cases may occur, and GenAI can help here. Then, actually mapping the fields or mapping an entire schema, right? That is, for each field, what type of conversion may occur, what are the guidelines, what is the target format, and how are we actually going to execute that conversion? Either for an LLM to actually convert later, or just guidelines for humans to use. But GenAI can take the source schema and the target schema and recommend this is how the fields would change and the transformations required. And GenAI naturally can also restructure the data themselves, that is taking either nested or hierarchical data and distributing them across various rows and entries. There are certain formats that LLMs have trouble with, such as nested formats such as JSON, but With RAG or with certain fixes, you can actually apply LLMs to these formats. Or even if they are not nested formats, you may just take data in a specific structured format and convert the structure to a different format. So what would be a full pipeline or sequence already leveraging GenAI at the transformation stage? We could start by detecting the dataset schema and the field types if we don't know this already. Then we would determine the target schema and the field types, what is the desired structure, data types, and so on. Again, the usual operations that you already know, but in an automated manner with GenAI. Then we would calculate the matching between the original schema or the original types and the target schema or target field types. In other words, what becomes what? How is the conversion supposed to occur? And finally, we could actually perform the conversion. It is changing the source dataset to a new schema according to certain conversion rules or criteria. You could leave this step to the humans, just do all of the suggestions and then leave them in a repository for somebody to take care of. Or the LLM can also perform the conversion itself as well. It depends on you and the workflow that you want to have. So how would an automated pipeline like this work out in terms of pseudocode? Well, we would determine the data schemas to begin with, right? We would extract the schema using the LLM instance and the dataset and obtain it as some sort of structured element. Then we would determine the target schema for that dataset based on the LLM instance, the instructions of what to convert or what is our goal in general, and maybe the source schema as well. I don't know if the source schema would be relevant here, maybe not, because we're just calculating what is the target here. Then, at the stage where we determine the mappings, then we would need both, right? We would call some sort of function that takes the LLM instance, the source schema, and the target schema, and just pretty much makes the conversion. What are the mappings as an output? And then, if we're using an LLM to actually convert that dataset as well, we would have some function that obtains the guidelines, either from human input or maybe from a repository such as metadata or documentation for a project in terms of that transformation, and then actually converting the dataset, right? Taking the LLM instance, the dataset, the specific field mappings, and the guidelines for the conversion. As for the other stages, we do have limitations and problems. What are some that we can face at this stage? Well, the field mappings may be imperfect to begin with, right? Especially if the LLM doesn't have specific knowledge of the fields, their purpose, types, and so on, it can map them incorrectly. For example, if you don't provide any context to an LLM, then you just say that there is a customer that needs to be converted to a different schema, it doesn't know anything about that customer. Is it a bank customer? Is it a health clinic customer? Is it a hospital customer? Is it a travel agency customer? Depending on the specific sector that you work in, the use case that you have, the dataset itself, and many other things, you may have entirely different mappings of a specific field to another field, right? The less context that the GenAI model has, again, the more that it's going to probably output a wrong answer. Then do notice that specific rules may not be translated, right? If you have specific fields such as prices that have business rules or validity rules that come with them, if you don't include those or if you don't include them in the specific conversion criteria, then conversion may miss these. Or even if you have them documented, but you don't tell the LLM to take them into account during the conversion, then it's not going to convert them, right? So it is important to take this into account. If you want specific rules such as business rules or data validity rules or data retention policies or anything else to be included, you have to include the source ones and you have to prompt for that when you're doing the transformation, because otherwise it's just going to be ignored or it's going to be done wrongly, none of which are a good option, naturally. And finally, you may have inconsistent naming, as we mentioned so many times in the past, right? If we use multiple passes and the context from those slides, the LLM may change the names and the definitions for similar subsequent datasets. And what is the fix? The same as always. Either you have an LLM that is fine-tuned on your specific jargon or terminology, or you remind the LLM of that specific terminology in every single answer, or you use RAG. But what you need to take into account is that the less that an LLM is trained on a specific term or a specific word, the more that it's going to forget it unless you keep reminding it of it. And the more that the context window slides and you ask multiple questions and you get multiple answers, the more that the terms that it doesn't remember are going to be reinvented or they gain new meaning, none of which are a good option again. In this lesson, we are going to transform data, which is also one of the most complex things that you could do with an LLM. But what we have here is an XML file and a CSV file. And what we want to do is to simply convert these to a JSON format, right? So one of them is a basic CSV file. Then another one is an XML file with customer loyalty data. And then we also have a relational table that is split with pipes and that is in text format. And what we want to do, as usual, is just run our pipeline script to get all of this converted, right? So I'm just going to change this. By the way, I don't know if anybody wants this script. I could put it on GitHub or something like that, but it's a very basic script, right? It's a Python script that just goes in, takes every single file, reads the prompt, adds the dataset to the prompt. Then the session with DeepSeek or the Ollama model of your choice was already opened at the beginning. So we just pipe a response to that connection, I guess, and then we get the answer. So it's a very simple script, nothing to it, but I may end up putting it somewhere if you want it. Okay, so what we're going to do here is, we're not going to run this yet. We're going to edit the prompt, and we are going to say, please transform. Let's remember that this is one data set at a time, right? Please transform the associated data set into JSON format. Please output the corrected data set. Please output the data set as JSON and nothing else. We do have to adapt this, right? Because I'm already guessing that if we didn't edit this bit, it would go haywire because it will try to generate JSON and a comma-separated data set at the same time, okay? Do not change any of the original data, just add incomplete values. I don't want this either. Please do not output any text except for the data set, in just the data set. This is perfect. I want to be able to copy paste your answer, not onto an Excel. So just the data set as output. Can you see how I'm repeating, I think it's 4 times here, just output the data set as text and nothing else. Anyway, let's see how it does. And what I'm going to do is I'm going to actually already tackle all of these at the same time and see how it works on every single one of these, right? The good thing about LLMs, right? One thing which is a strength of an LLM is that as long as something is in text format, it can easily parse it. So this is one of those situations where we don't need an XML parser and a CSV parser and a text parser. As long as you can copy and paste it as text and put it in the prompt, it can probably process that file, right? The bigger challenge that we're going to have here is to make sure that the LLM doesn't change any of the data, which is going to be a big one, right? Because LLMs have a tendency to change the data in some way. So it's outputting this as CSV. I don't know why it's CSV, but I think that this is my own problem. Maybe I'm the one who is outputting this as CSV. Oh, no, I know why it is. Because I think that the script blindly converts the outputs with the same file name as the original file, right? So because the original is CSV, this one is CSV. Again, this is a script issue. It's not an LLM issue. If we change this to JSON, for example, it actually output the JSON, which is excellent, right? Are the fields consistent? The fields do seem to be consistent, right? Product ID to product name to quantity, price, shipment method, and the text seems reasonable. The support tickets was converted to. Let's just take a sample here and gauge whether this does make sense or not, right? So the support tickets, ticket ID, customer ID, let me select the whole row to make it easier to visualize it, right? So ID, Thomas Smith, T. Smith, right? Phone number checks out, date checks out, account type checks out, okay? So this actually seems reasonable, right? Again, if the data are very sensitive, we should have some sort of routine to actually gauge whether these data were well converted or not. Or another thing that I didn't even mention, we could actually put this in a new LLM, right? We could literally say, hey, here is an original data set and a converted data set. Can you please take a look at these two and gauge whether any data were changed? Boom. That can be done too. You could fine-tune an LLM to look for that in specific, but it should work, right? Loyalty program too. Let me just take a look at this. So we have member ID, personal info, name, email, phone, birth date, right? It seems like all fields are here. And you can see how this example shows one of the strengths of the LLM, which is that it can convert any of these formats to the target format. What we could also do here is if you're doing a data transformation project in specific, you would have a list of fields, right? You don't just run this in an automated manner and say, hey, please convert the files and let's hope for the best. No, you would have a list of necessary fields, a list of the target fields, a list of the source fields, maybe even information on the actual mapping. How do we convert a specific number to this new format? And so in that case, you would have more information to add here. But in this case, we would just say something like, hey, please attach the structure that the output JSON must have, right? And we would have something like product ID, full name, something like that, right? And in certain cases, the LM can even understand certain things intuitively. For example, if you have a first name and a last name, and you are asking for a full name, it knows that it should join the two with a space. But in many cases, it's good to literally specify every single field that you need so that it can perform the transformation in this case, right? In our example, I'm converting a lot of different stuff to JSON that doesn't have a specific structure because they're all different, right? We have support tickets, we have loyalty information, we have purchase records. But usually you would do data transformation for one type of data at a time, one type of entity or class or a representation of a specific object, and the structure is always the same. And then when you want to do it for a different type of data, you would do it with a different format, right? But again, I'm just trying to show you a very quick and simple example in 5 minutes with a simple model of how you would set up a very simple script that takes the data, converts them according to a set of parameters, and then outputs the data in the converted format. So as we see, GenAI can be a powerful ally in creating an automated pipeline for the transformation stage. But a lot of the problems that we discussed with individual operations again may occur here as well, which is imperfect field mappings, inconsistent translations, and more. We are now at the end of our real-time integration module, where we covered how to use GenAI to create automated pipelines that perform data operations using those GenAI models. Let's take a moment, as usual, to recap the content of this module and cover our key takeaways. We are now at the end of this module on using GenAI for data operations in automated pipelines. In this module, what were our main topics of focus? Well, one was just a general view of automated pipelines that include generative AI, with multiple steps, using LLMs in specific to produce results, be it in terms of creating rules, converting data, or many other things in an automated manner for all of these different stages of the data lifecycle. Or for example, examples of automated operations such as fixing incorrect values, cleaning data, transforming data, generating validity rules, converting those rules, and many other types, and how they're done using GenAI. Or common operations, as well as the common issues and risks for every single one of the data stages covered. Does it slow data ingestion and processing? Does it create bogus rules that don't use the same terminology? What are the risks at every single one of these stages? And what do we take away from this module? Well, for one, GenAI is demanding in terms of computational power. So while it does allow new operations and very nifty ones in terms of documenting data and doing all of those things, it does also introduce either latency or a reduction in speed or scalability of the current pipeline. So we may have a use case that allows for that and that is flexible, or we may have a use case where that is not allowed at all. So either we change it or we need more resources. Or for example, GenAI may become inconsistent. That's another thing to remember, right? Especially when you're doing multiple passes and the context window slides or multiple operations, as the context changes, certain meanings change, especially if the LLM has not been fine-tuned on those specific words, or if you don't keep reminding it in every single prompt, right? So using RAG and being specific about the names and the terms constantly always helps here. And also, if it wasn't fine-tuned on specific knowledge, as we just mentioned, right, terms, rules, or definitions, GenAI may miss these or it may be imprecise in generations, right? Wrong names, inconsistent terms, rules that are skipped altogether, and so on. Unless you keep reminding an LLM of what a specific term is, or unless it has been trained enough to really know what the term means, at some point it's going to forget the term as the context window slides. And when it forgets what the term means, it just makes up a new definition that is probably true based on your context. But what is probably true is not enough in a lot of cases. So either you need to constantly include that name in the prompt or the LLM, or use RAG, or all of these. And with this, we close the real-time integration module, where we discussed how to use GenAI to perform these data operations in an automated and sequential manner. Welcome to this module on using RAG for data quality. Here, we are going to focus on how to use retrieval augmented generation, which improves LLM answers, but specifically to improve answers related to GenAI in data operations at the different stages. Let's take a moment to cover the lessons and topics for this module. Welcome to this module on using RAG for data quality. That is, when we're using GenAI for data operations, how can we use RAG to improve the quality of our answers? What are we going to cover in this module? Well, for one, the basics of RAG. That is what it is, what is the technology, what are its benefits, how does it integrate with the LLMs, what is the pre-processing stage, and what is the general process for using it for data operations. Or various use case examples of using RAG in a GenAI pipeline, such as to complete data, augment data, generate metadata, and more. So basically applying RAG to the tasks that we already know, or appropriate prompts, data sources, and process steps for the various use cases, getting a little bit more tactical now for every use case, including the documents to be pre-processed and the generation of LLM answers with RAG. For this purpose, we have 5 key lessons in this module. Lesson number 1 is about working with RAG for data in general. That is, what are the basics of using this technology, some considerations, the general process, and so on. A snapshot of what RAG is. Then our second lesson is going to be about RAG for completing data. That is, how to use GenAI to help us complete missing or incomplete values and using RAG with added documentation in that process. Then our third lesson is going to be using RAG to actually augment data. That is, using RAG to add values or add context based on those existing documents that we pre-process. Then lesson number 4 is going to be about using RAG to generate metadata. That is, using RAG to help create metadata for existing datasets based on existing metadata or documents that we may have. And then lesson number 5 is about using RAG to transform data. That is, using RAG to actually change schemas or formats based on existing documentation. As usual, we perform this task, but we use additional documents as context for RAG to improve our answers. So as you see, this module is all about using RAG. If you are already performing satisfactory data operations using GenAI models, now here we are going to cover this additional technology or additional layer to improve those operations in all areas. Let's talk about working with RAG for data. That is, how do we actually apply RAG to an LLM, to an actual model, and how do we use it for data operations? So what we're going to cover in this lesson are some basics of what is RAG as a technology, what is the general process, such as pre-processing the documents, creating the embeddings, indexing the embeddings, and then actually matching a prompt with an embedding and generating an answer based on that, and more, but specifically when using GenAI for data operations naturally. Let's take a look at all of this content. Welcome to this lesson on how to work with RAG when you're using GenAI for data operations in general. RAG, or Retrieval Augmented Generation, is a type of technology that allows us to complement an answer of an LLM with specific data elements from processed documents that we have to pre-process beforehand, but then we can use them for additional context. And this improves our answers and reduces hallucinations. As mentioned, it helps provide additional context and information to an answer, as well as keep hallucinations in check because the information that we use is more granular. And essentially what we're doing is, we're transforming existing documents into a format that can be later fetched. So, when we enter a prompt into an LLM, the RAG mechanism is going to fetch the most appropriate piece of documentation and embed it in the answer. In general terms, what is the process for embedding an RAG mechanism into an LLM? Well, first we prepare the documentation to be used because we have to pre-process it first. We have to create what we call the embeddings, the vectorized version of the information. And this includes extracting text from documents, such as parsing PDFs, because remember that LLMs only work with text, so that information has to be in text form. Then, the step after that is creating embeddings from that text with an embedding model. So it's a specific model that transforms that text into specific embeddings. And then we have to index these vectorized forms or these embeddings with some sort of similarity search index. So basically, we transform the text into embeddings, we index the embeddings, and later we're going to use these. And then simply, we ask the LLM questions, fetching the embedding data, right? The prompt is also converted to an embedding, and then it's matched with the most appropriate piece of a document, the most appropriate embedding of a given document based on the content of it, using that similarity search index that we've created before. And then the prompt and the fetched content are provided together to the LLM as the full prompt, if you will. So the appropriate piece of the document is included as part of the prompt. And then the LLM fetches an answer based on this full prompt instead of just our prompt. And then the answer is going to be more refined because we are refining the prompt as well with additional information, be it in terms of specific terminology, specific terms, actual information or data that may complement our prompt, or anything else. And additionally, if we provided specific metadata when we created embeddings, such as chapter numbers, document IDs, and so on, then what happens is, when we fetch the appropriate embedding, then the answer is going to take into account those metadata. So it's going to be able to tell you this answer is based on specific chapter 4 of a specific book or whatever document you have embedded. There are, however, important considerations to take into account here. One is that the embedding model is its own model, right? So this means that it may be a general model or a fine-tuned model with specific knowledge or with general knowledge, with the same language or different language from the LLM that you're using and your documentation. So it's another model to manage in a way, right? So the same effort that you put towards selecting an LLM also must go here. Are you going to fine-tune it? Are you going to teach it specific terms and terminology? Are you going to run the risk of it not matching the terminology that you use in your organization, and so on? So ideally, the dream scenario is that both the LLM, the embedding model, and the prompts that you use the same exact language. The specific example that I'm always using in this course, right? The definition of revenue, for example, is the definition of revenue in your organization the same for all departments and for all geographies? And does your LLM, your embedding model, and your prompts use the same definition of revenue? Because if not, then you are going to generate or fix data in an inconsistent manner. And a great segue to this is that the language must be similar, right? So if you're using the main jargon, for example, then the LLM, the embedding model, and the prompt may be describing things in different ways. Such as, for example, financial statement versus a balance sheet, right? So even if the models are trained on the same language, you still have to use the same language in the prompts and the documentation that you are embedding. And this is a trap that is easy to fall into because even if you train your models and use the same language in the prompts, if you include a document and you create embeddings based on that document that doesn't use the same language, that's already enough to destabilize your results. So we have to align the prompt terminology with the document terminology, if you will. They should all be consistent. And then the embedding metadata and context are optional and they are manual, right? So for example, the only way for RAG to know that a specific piece of knowledge comes from that annual report, page 12, is for us to manually tag every single page in that annual report, or the chapters or sections and so on. So as you see, creating the actual embeddings for use with RAG quickly becomes its own task. And the more documents that you want to use and embed in answers, then the more work that you are going to need to have, right? There are certain ways to automate this, but it's not always that clear or that fast. So it's another trade-off. Do you want higher granularity? Well, then you're going to need a higher amount of work as well. And naturally, if we don't tag these specific sections, then RAG is not going to be able to track them. It can tell you that a specific answer came from information from a specific document, but where in that document? And depending on whether you are including text from a PDF with 2 pages versus a PDF with 200 pages, then the section may become a lot more relevant, right? And in general terms, we also have a couple of best practices here. So one is to ensure language consistency everywhere. I'm kind of repeating myself a little bit, but this message really is important. So you want to make sure that the LLM, the embedding model, and the prompt use the same language. And you want to fine-tune or train appropriately to reach this result. And this is easy because once you reach a certain level in your metadata or document repository where the terminology is standardized, you are going to use a lot of the same documents for a lot of things, such as training different models. But still, it has to be done. Then you also want to consider various combinations, right? Domain-specific models may be more useful than general models. Just like a model with the unique terminology of your company will be more useful than a generic domain-specific model, right? For example, if you have an open source LLM that has not been fine-tuned versus an LLM that has been fine-tuned in terms of financial data versus an LLM that is fine-tuned in terms of financial data and that you have fine-tuned with your own domain knowledge of your organization, then the definition of revenue, for example, in those 3 different LLMs is going to be very different, right? Or not very different, but it may encompass specific nuances that you want it to encompass. So the more that you can guarantee alignment in terms of the language, the better. And finally, the information must be up to date and it must be correct. This sounds simple, but it's worth mentioning. Look, if the documentation used for RAG contains wrong information, then the LLM is going to feed you wrong information, right? Garbage in, garbage out. If you work with data, you know this better than anybody, right? So the documentation that is going to be used to support the LLM must be documentation that, for example, if it mentions a product or a software or whatever it is, you need to take into account the most recent version. Or if you're talking, for example, about financial statements that have been later amended or that have been changed in some way, then you need the version that is the most up-to-date, right? So the knowledge management of the documentation that is going to be used for RAG also matters a lot, because otherwise you are going to have inconsistent results, right? And then you are going to have bogus LLM answers, and then you track them back to a document, and then you figure out, oh, somebody didn't update this document or regenerate the embedding to use in the LLM, right? And you could have saved that time. So how would we include RAG for our data operations when we're using GenAI? Well, it's no different than the generic use case. The first is you want to create document embeddings that are based on your specific use case, right? We want to index text that is similar to the data values that are to be filled or the metadata to be created or whatever our data operation is, right? If you're filling missing values in terms of financial transactions, for example, you want to create embeddings of documents that help you with those transaction data. If you're trying, for example, to generate metadata for customer information, then you want to add documents for RAG that have to do with existing metadata, for example, right? So your use case dictates what documents are going to be the most useful that you need to pre-process and create embeddings of. Then we feed the LLM the data and the prompt as usual. And what's going to happen here is because we have an RAG mechanism, it's going to retrieve portions of our embedded documents that most match our prompt and our data. And the most relevant embedding of a document is going to be included in that prompt together with the data and the indications of what to do, how to transform data, how to generate data, or whatever your specific task is with the most appropriate information as additional context. And then the LLM answer is going to take into account these portions of the additional documents when generating the answer. It's like we're magically saying, here's the data, and here's a relevant portion of a document that we sourced from somewhere. Now do this to the data. Again, it's based on similarity in terms of text. So you want to embed documents that are relevant to your data operations. Otherwise, it's not going to be a lot of use. But if you do that, then the RAG mechanism is going to fetch the most appropriate pieces of that document and deliver it alongside the prompt. It's as if we're magically saying, hey, here's the data, here's what you should do, and here's a piece of additional context from our documentation that illustrates what you should do. And then the answer is going to take all of those into account. And just to close, a quick example from the financial world, right? So if we want to fill in missing transaction values, the usual use case that I'm always mentioning, let's say, for example, that we have a data set of 50 transactions with the missing amounts, right? The actual financial amount. What we want to do is first we embed and index relevant document text. So in this case, it may be annual reports with transactions, it may be interbank records, it may be internal reports that contain those financial transactions, app logs, banking history, or anything else that is relevant to those transactions. And then we use a model that is fine-tuned on financial services jargon or terminology to create those embeddings because it understands the lingo better. Maybe a general one could work here, but we have a specific one, so we may as well use it. Then we provide the LLM with our prompt in this case, right? It includes the dataset and the operation to be performed, something like, please fill in the missing values and take into account the relevant documentation. And what's going to happen is the RAG mechanism, before delivering the prompt to the LLM, is going to fetch the relevant portions, such as, for example, rows from 100 to 150 of an interbank record Excel file, or 20 lines of application data logs with transaction IDs, or anything else that may be relevant. And then the final answer simply takes into account the relevant text, right? The amounts are filled based on the document text that we have retrieved. It's as if we are including the prompt, the dataset to fix, and magically the most appropriate piece of content that is going to help us here. So in this module, we are going to tackle RAG, or Retrieval Augmented Generation. And we are going to have another simple script to deal with this. But essentially, what we do here is the following. We start by having a group of documents and we pre-process those documents, right? We take those documents and then we create embeddings from those documents. And I used specific libraries for this in a very specific implementation, which is a very simple one. What we do is we create the embeddings, we create the vectorizer, which is an object that is able to convert the parameters of our query into embeddings as well. And then we have a similarity search index. In this case, we use the FAIS, Facebook AI Similarity Search Index. I don't know how to pronounce it, but essentially, it takes the embeddings of the documents and the embeddings of your prompt, and it matches them in terms of similarity. Or in other words, it finds the portions of the documents that you have, which are the most similar to the query. It's a way of magically finding the most relevant text in your documents and then including it with a prompt. And then what happens is you are able to track the answer to specific documents or specific portions. We also do that with tags, which we are going to take a look. But I created a very simple script. In this case, we would have two steps, right? Because first, we wanted to index those documents. What I did essentially was I assumed that we already had the documents as text, right? You may have to extract the text from PDF, but again, the goal of the course is not to show how you would extract or pre-process that text. The goal of the course is to assume that we already have text and to then pre-process it, right? So I'm going to run this indexing script that takes the documents and then creates the embeddings from them. And then I'm going to run this test script, which essentially feeds a prompt and asks for something. And then it's going to fetch the appropriate documents based on those embeddings, right? So very simple, two steps. We create the embeddings from the documents and the vectorizer. And then when we run a prompt, we are going to include those embeddings, but specifically the ones that have the highest level of similarity, which is done by analyzing their similarity in their vectorized form. We'll take a look at this in the next lesson. As we see, RAG could almost be considered a magic type of technology that takes the most relevant piece of information to your specific prompt, embeds that information, and subsequently generates a better answer as well using the LLM. Naturally, it does have drawbacks, but it's very important to use because it can increase the quality of your answers, which is crucial when you are trying to actually fix data with those LLM answers. Let's cover a quick example of using RAG in data completion. That is, we are using GenAI to help complete the missing values in a dataset, and we are going to use RAG to increase the quality of our answer in terms of that LLM. Let's take a look at this example. Welcome to this lesson on using RAG for generative AI in data operations to complete data in specific. Let's say that we want to fill in missing database values, for example, missing financial transactions in a bank, just a simple use case. So what elements are we going to need in order to perform this operation, including RAG? Well, we're going to need the data, right? The data to complete, that is the transaction data set. Then the RAG data, right? The documents that we want to create embeddings of. And here, it may be internal documents that provide more context, reports, employee notes, related database entries, meeting minutes, and so on. Very similar to the financial example from the previous lesson. And then the actual prompt, right? Something like an indication of what values to augment and how. What are the formats and what are the rules? What should you do if there is no value? What should you do if there is a value but it conflicts with other sources of information that you should have, and so on? What are the criteria for completing those data? So what would be our general procedure, including RAG, for this process? Well, we start by identifying the data that are missing or incomplete. Nothing new here. In this case, the transactions to complete. Then we want to process the supplementary data or the additional data to use in RAG. That is the meeting minutes, notes, documents, and so on, creating embeddings of those. So we pre-process these, transform them into text, and create embeddings, that is their vectorized form, and possibly adding the metadata for the chapters, the volumes, the rows, whatever it is. Then we generate the missing values themselves using the LLM, right? We fill in the missing amounts in transaction entries. So include our prompt, the dataset, and then RAG is going to take care of including the most relevant piece of these supplementary documents. And then we validate the data in some way, optionally, or we run some sort of statistical analysis just to make sure that the LLM did its job well. So we may validate the justifications or the confidence scores that the LLM included if we have asked for these. And we may also run statistical analysis to find anomalies or glitches. What are some examples of prompts for this specific use case? We could say something like, please complete the specific values from this dataset. We could also say, use the data from this specific source as supplementary information, the most relevant document piece that is going to be included, and possibly assign justifications based on the retrieved data and attribute a confidence score to all generated values. In other words, if we have documentation that allows the LLM to make a very good estimate of a value, it may have a confidence score of 90%. If we don't have any relevant information, then it may estimate the value, but the confidence score may be 30 or 40%, right? So that's why we ask for additional granularity optionally. In this lesson, we are going to use RAG to complete data. So what we are going to start by doing is indexing the documents, right? Creating the embeddings. And what I decided to do to illustrate how we can attribute specific tags for a document page or portion, I have done a version which is a little bit more complex and where we split the documents into specific sections versus having the full documents. But we'll get to that in a minute. So what we essentially do is we run the indexing script first, right? And what it's going to do is it's going to create the embeddings, right? And as mentioned, we do have the numerical embeddings, we have the document metadata with the tags, and we have a vectorizer that is able to establish that comparison later. So what I decided to do here is when you input a document, such as, for example, an expense policy, if in the answer you want to know, hey, what specific part of this document was relevant to the answer that I obtained, what's going to happen is you are going to need to tag that document. So in this case, we tag it as expense policy, and then we also have a tag file for this meeting minutes. And then what's going to happen essentially is when you generate the answer, it's going to tell you the most relevant document was meeting minutes or expense policy. But what you can also do, which gives you a more granular approach, is I also have a version where I broke down these documents into their specific sections, right? Expense policy section 1, section 2, section 3, etc. I kept the header. But then what it allows you to do is, because I have the tags for every single one of these, section 3, section 2, when we create the embeddings, we can also attribute that tag for that specific section. And then what happens is, when we are inputting the query and RAG is fetching the most relevant portion of the document, it's going to fetch not the whole document, but the specific portion with the associated tags. And you may think, well, this is a little bit of added work, right? Because if we want to tag a specific page or a chapter of a document, which usually can even be in PDF. We have to extract all of the text, then split it according to that specific section or page or chapter, and then tag every single one of them. And yes, that is true. So you want to decide what is the level of effort that you want to put into this, because then you get the appropriate reward, right? If you just tag a generic document, then you are just going to know that we filled values using information from this specific document, right? But if you go the extra mile and you tag the very specific sections of this specific document, then for the values that are missing, it's going to tell you we filled this one based on section number 2, we filled this one based on section number 3, and so on of this specific document. So again, you decide how deep you want to go. I'm going to show an example of both of them. So we run the indexing script to create those embeddings, and then we run this get answer script. So this get answer script is actually a simple script that is actually even simpler than our pipeline ones. The only thing that it does is it retrieves the contexts, that is the chunks of document text from those embeddings. It starts a new OLAMA client. It loads the prompt and the dataset. So we are going to have the prompt in a text file as usual, and we are going to have the dataset in another file as usual, right? And then it simply creates a full prompt that includes the list of the documents that match the answer the best, together with a prompt that we want. Do we want to remedy data? We want to standardize data. What is that we want to do? And naturally the full dataset, right? And then it's going to output the answer, in this case in the terminal line, because we don't output it to a text file. But it's very simple, right? It's a demonstration of what did we fetch from those documents and which were the most relevant in treating those data. Okay, so let's start. We have a simple prompt here, which simply says, please fill in the incomplete values from this dataset using context from the additional documents provided, okay? Very simple, and we have our transaction dataset here. I think that I have already changed the paths in this text file to match these, which, yes, I think they are correct, transaction dataset and prompt. So we can simply run this and see what we get, right? So we are going to run the get answer script. So it's printing in the full prompt. So it's processing these file names. So this is part of the indexing still. Okay, so this is our answer. This is our question, actually. This is the prompt, full prompt with the documents, with their similarity scores to the specific prompt that we have, right? And then the query and the data set. And now it's going to generate an answer based on this, which is going to take a couple of seconds, I assume, because there is a lot of text, right? And this is also something that we do need to take into account, which is that when we are generating an answer with RG, it's going to take longer, naturally, because it's loading those chunks of text that are the most similar to the prompt. And also, it's important to notice that you may exhaust the context window sooner. Why? Because there is a specific context window, right? As the context window slides, the LLM only remembers the last amount of tokens of text. And because instead of having a short prompt, you have a gigantic prompt with text attached, you can exhaust that context window a lot sooner, right? In this case, because we are, obtaining the answers one at a time, it's not a problem, but in long conversations, this can become a problem. So final answer, right? So we have the thinking process here as well, right? These documents relate to company operations, etc. Source tags. You can see the source tags here, right? So this is the tag of the document chunk that is the most similar to the query that we have to fill in the missing values in our dataset. In other words, it took those documents that were pre-processed and it came to the conclusion that the meaning minutes is the one that contains text that is the most relevant to the specific query. So it included the full meeting minutes text as well. And now it's generating an answer based on this, right? So this is the final answer. We have expenses here. I think in this case, we did not have the expense categories, if I'm not mistaken, right? Expense type, travel, meals, equipment, consulting, office supplies. So I don't know if it's the expense categories that are missing or what other values were missing, because it's a dummy data set. But at the end of the day, we can see that the answer says, hey, the most relevant document to help fill in these missing values is the meeting minutes. Why? Maybe because it has project codes and the project codes are in the meeting minutes. Maybe because departments, vendors, whatever the information is in the meeting minutes, but that's the most relevant one. So now what we're going to do is the following, right? Remember that we generated the embeddings for the generic version, right? The simple version. So I'm going to rename this and I'm going to use the complex ones now. And this contains, again, the same meeting minutes file and the same meeting minutes expense policy, but broken down by sections, right? Section 4, expense documentation. Section 3, payment methods. And it contains tags for every single one of these, right? So now when we attach a specific document to that prompt, we are going to have the tag for this specific section of the document, okay? So we are going to start from scratch again, and we are going to index this. And I think that the indexing is actually very quick, right? Because we have a low quantity of documents with a low quantity of text. If this was a production environment, things could be different. And now we are going to obtain the answer again. I don't know if it's going to take longer this time, but we will find out. We can already see here, right, even before the answer is generated, that the chunks that most match our prompt were meeting minutes section 2, project discussion, then meeting minutes section 2, project discussion again, and then meeting minutes section 3, budget discussions. Why? Right? Because it breaks the prompt into chunks as well. And then it's going to compare those chunks with the chunks of text in the original documents that we attached. So you may have a situation where different chunk of text in the prompt match the same chunk of text in the support documents, which means that the documents are very relevant, right? So we have a very long answer, right? This is the query, retrieve context, thinking process. And what is the output, right? Final answer. We can make educated guesses. So it did not output the actual data set. It output the rationale and the specific fields. As we know, this happens sometimes. So what we do, we go to the prompt and we say, please fill in the incomplete values using the additional documents provided. Please output just the data set and no other text, right? We could even take this a step further and say something like, please add a new column where for each entry, we include the most relevant document section. Call this column completion reference, for example. I would add the usual ones, such as the confidence score and justification, but it may be asking too much at the same time, and then the LLM is just going to go haywire. So for now, I only want it to fill the missing values and to add this new column called completion reference. And let's see whether it actually does this or not. Let me again emphasize, please just output the data set. I get the feeling that half of this course is me writing down the expression, please just output the data set. But this is prompt engineering, right? Okay. So now we have it. Again, we can see that the section 2 project discussion matches multiple chunks of the prompt, and then budget discussions matches one part of the prompt. In other words, the project discussion is very relevant and the budget discussion is somewhat relevant. And all of the other documents are not that relevant. You could also tinker with the sections, right? Because you can change the size of the chunks, you can change the terminology that you use, and that way the way that the words are matched can be different, right? If you have things like revenue versus profit, there are certain words that if they are not equivalent or the terminology is slightly different, then they won't get matched, right? Remember, the model that creates the embeddings should have the same language as the model that you use for the LLM and the language in your prompt too. So here, we can see, based on the analysis, here is a structured approach to filling in, right? All fields, department, etc. So it's still not giving us what we want, right? It's kind of outputting a guide. A structured approach provides a clear picture of the transactions, right? I don't want this. I want the actual data set, right? Maybe it's my mistake. Maybe I didn't ask for the actual data set. Please fill in the incomplete values, right? Maybe you want to change the wording of the prompt and say, please output the data set with the incomplete values completed, right? Using context from the additional documents. I think that this part is actually, we don't even need to say it because the chunks of text are going to be attached in the actual prompt. So the information is going to be there. So please output just the data set with the completed values, with the completed incomplete values. I'm trying to think of how to phrase this in a way that doesn't confuse the LLM. Please output just the data set with the incomplete values completed and no other text. Please just output the complete data set. Okay? So this should get us closer to what we want. But again, you can see the general process here, right? We took our documents, then you want to go to any level of specific depth, right? You may want to break them by portions or chapters or not at all. You may want to tag them or not. And then you create the embeddings using some sort of model and you pick the model. Then you run the pre-processing step to index those embeddings. And then when we are obtaining the answer, the library that we're using is fetching the most appropriate embeddings. And now we finally have the data set, right? And we can see that, for example, for this entry, the most relevant section was section 2, travel expenses completed, right? Section 3, equipment purchases completed. I don't know why it's saying completed at the end of every single one of these. Maybe it's saying that it was completed due to this section. Either way, it's not an issue, right? We can change the prompt and get us closer to what we want. But you can see how this goes, right? We could even integrate this with a pipeline where we have an initial pre-processing step that is done once, and then we have some sort of watchdog like we had on module number 5 that takes each file, fetches the appropriate embeddings, gets the answer, outputs it to its own file, and has the references to the parts of the document that are the most relevant, right? But at the end of the day, this is how you would use RAG for completing data in specific. So as we see, the process is very simple. We do have the pre-processing step to create and index the embeddings, and then we simply use that information in the answer when we are actually fixing the data using the GenAI model. Let's talk about using RAG when you are using a GenAI model to augment data, which is a use case that just feels right? Because you are using additional information to help insert additional information in the dataset. Either way, we are going to cover the general process, including RAG. Welcome to this lesson on using RAG for generative AI in data operations to augment data in specific. So let's say that we want to augment an existing dataset, for example, a set of customer profiles with additional information from sources such as credit reports on those people, market data in general, demographic information, or even activity from social media. So what elements do we need in order to perform this task with RAG? Well, the data is going to be the usual data set, right? The customer data that we wish to augment. Then the data to use in RAG are going to be those additional sources of supplementary information, the reports, the records, the demographic data, the social media posts, whatever it is. And the prompt could be something like an indication of what additional fields to include and how to combine the information to generate those additional data. So what would be our general procedure to integrate RAG into this pipeline? Well, we would start by identifying the data to augment, right? In this case, the customer profiles or database entries that we want additional information for. Then we process the supplementary data to use in RAG. You know this by heart by now, right? So the credit reports, the market data, the demographics, and so on. We take them, we convert them to text, we create the embeddings, we index those embeddings. So pre-processing and creating embeddings as mentioned. Then we use RAG to actually merge the data or to add the new data, right? So we add, for example, a new group field to customer entries or whatever it is. And we simply pass on the prompt and the dataset to the LLM, and the RAG mechanism is going to fetch the most relevant pieces of information from the supplementary data. And then possibly we may validate the generated data or run some sort of statistical analysis as usual, just to make sure that the LLM did everything well, right? So we may validate that the new data are congruent with existing values, that there isn't any new field that is completely different from the previous fields or that doesn't make sense, such as, for example, a customer being 70 years old and being grouped into a demographic category, which is, for example, 20-somethings to 30-somethings, some big mistake like that. And we may also validate the confidence scores or the justifications if we ask the LLM to provide these. What would be some prompting examples in this case? Well, we could say enhance this dataset by adding a new specific field, for example, or even ask the LLM first what additional fields could be useful. Then we could say for this new field, use data from this specific source or sources. Because if you are including multiple sources of information, you may just want to use some of these, for example, for a marketing field or others for a financial field or whatever type of information that you're trying to embed. And then saying something like ensure that the new data are congruent with the existing data and values and don't change anything in the existing data. It's always a good practice to never copy paste the previous data after it has been run by an LLM anyway, because even if you ask it not to change anything, it's still going to change something. So good practice is, for example, just taking the new column and copy pasting that column into the dataset or integrating it, but not running the original data through an LLM and taking what comes out the other side, because usually it's always changed in some manner. So in this lesson, we are going to tackle how to augment data with RAG. So essentially what we're doing is we have a data set of products and we want to augment this data set to include, for example, the target demographic or the key features of a product. And for that purpose, we have a set of documents here, such as an industry report or a set of marketing materials for these products, all of them which contain useful information naturally. And what I'm going to do is I'm going to show you the process of tagging these text documents to be a little bit different from the previous one because I showed you how it was when everything was already done. But for now, I'm going to run the basic version of this prompt, right? So I am going to run the indexing script. I have already made some changes so that it's a little bit more flexible and we can change the folder and it tackles each subfolder. So just a little bit of coding here. And we can see that it generates the generic embeddings, right? But we don't have any tags on these files, right? So as the prompt, I just said something like, please add a new field target demographic to the attached dataset, output just the dataset, and create a new column called augmentation reference, which is going to tell us what was the most relevant chunk of a document that was included in order to add this new field. Now, this is a bit of a trap, right? Because what happens is we don't have any tags. So it has absolutely no idea of what is the tag for the most relevant version of a document. So what I'm going to gauge is how does it do it, right? What is it going to say? Knowing the LLM and how it works, it's probably going to output something that seems reasonable, but that is not a tag or a document section, right? It's maybe going to point to a part of a document, but it's not going to be the document section. Okay, so what do we have here? Well, it actually improvised and it said that, okay, busy professional seeking smart home integration and ease of use, connectivity and voice assistance. And it says reg doc marketing materials.txt. So this is interesting because we didn't include any tags. It's actually fetching the document name. This is interesting, right? But what we want to do is we want to take it one step further, okay? So we are going to delete our embeddings and we are going to regenerate them. Okay, so I created a structure where the tags are in a file that is just named with the same name as the document, but underscore tags. So let's call it, for example, industry report. And now this one, sorry, I opened it by accident. This one should say marketing materials, right? So I'm showing you how to take this through progressive levels of tagging. So now we're going to create the embeddings again, but with the tags attached, right? You can see that there are tags in these. And now we are going to run exactly the same answer. But now, hopefully, it's going to use the tags instead of just the document name. I don't know if I actually asked for the tags. We include the most relevant document section. Okay, I didn't call it the tags, but maybe it's going to draw that association by itself. It's going to make that association by itself. Or maybe not at all, right? So I'm eager to see where it goes. And again, you can see that the answer takes a little bit more to generate. Okay. So augmentation reference, document 3, document 4. I have no idea where this is coming from. Okay, most relevant document section. What I'm guessing is that there is some sort of internal numbering system in the document, and it's including this, okay? But, okay, this time it was actually less verbose, right? You see just business professionals or gaming enthusiasts, so it's a little bit more concise. And again, because we didn't mention the level of depth that we want for the target demographic, we cannot assume that. So let's change the prompt into say target demographic. And here we include the tag of the most relevant document. And let's also add to the attached dataset. And you notice that we didn't even mention what the target demographic field means. Just due to its name, the target demographic, it already understood that by language association. So now let's add something else, which is, okay, so the target demographic is there, but I would say this field should contain a profession or hobby, an age, and one or more genders, an age bracket in this case, right? And now let's see if it gets more specific, okay? So what I wanted to do is to generate the age range, the gender or genders, the specific profession or hobby or interest, and also include the specific tag for each of the documents, which is not a granular tag. It's just a tag for the document itself, but it's the intermediate step. Then we'll break the documents into specific sections and we'll regenerate the embeddings, okay? Again, taking a little bit to generate this because there's so much material to include in the prompt, and it's doing that similarity calculation, and it's including, and it's regenerating. So I'm just making excuses for the LLM at this point. So document 000, document 10, it's not exactly giving us what we want, right? there are certain things here, for example, gamers, age 24-40, 45-55, both genders. So it's giving us a distribution of genders on top of the age and the interest, which is interesting. But it's frustrating that it's not including the tags. So it says here document 000, document 12, document 10. This is interesting. So it's using the similarity score of the document as the document name, which is not what we want, right? Because we do have the documents here. I'm guessing if there is some sort of internal numbering system that is kind of messing the answer. But this doesn't make sense because we do have the tags of those documents included. So it can fetch those tags. In fact, it only matched the marketing materials document. So it's saying that the industry report is not even relevant to our specific augmentation request. It's just the marketing materials. If I change the prompt to be about the market outlook or the industry, maybe it's going to fetch the other document instead. But here's what we're going to do, right? We are going to kill these embeddings. And now I'm going to split this marketing materials document into multiple sections, right? Or multiple products. And what I'm essentially going to do is create one section per product and tag them accordingly. And then that should be more granular, right? So in this case, Ultrabook. And then I'm just going to create a copy for every single one of the products, which could take a while. Maybe I'll just limit this to 2 or 3 products just to see the specific tags or the specific matching, just to show you how it's being done, right? This window is also pestering me. And now Power Tower. We got the Ultrabook, we got the Power Tower, we got the watch fit. And I'm essentially just breaking the document into the individual products, right? I'm keeping the first section because it's something that we may want. We may want the product catalog keyword in some way because it may help us or it may be something relevant, right? Home Hub Smart Speaker. So here's what I'm going to do. I am going to take away this one, and I'm just going to include the generic tags here, or the specific tag, sorry. So I'm going to say something like marketing materials and another tag that says marketing materials home hub, right? And I'm going to replicate this for every single one of these and just give them their own tag. Because ideally, I want each entry about a product to specifically reference the portion of the document, right? So this is Power Tower Gaming Desktop. I'm going to try to use the full name because you never know, it may be better. So this is Home Hub Smart Speaker. And we got the Home Hub, we have the Power Tower. Now we need the Ultrabook. What is the full name? Ultrabook Pro 15. Then we got the Watch Fit Health Tracker. So you can pretty much see what I'm doing here, right? We broke this document into sections. Ideally, we would have every single section for every single document. And now we have the specific tags for the specific materials, right? And this way we can get the aggregate, such as a marketing materials tag, but also the specific tags for the specific products. I am tempted to also include the full document here, but I don't know if it's going to mess with the results because, for example, if it matches the Ultrabook laptop, it would match this document and also the full marketing material. So I'm going to exclude it for now. And I'm just going to put it here in its own folder, quarantine from the world. So let's index this again, now with the specific document and the specific tags, right? Industry report, marketing materials, Ultrabook. So you see that we have a lot of different things here. And now we are going to run the get answer script. And immediately, what are the things that match, right? We have, for example, a match with marketing materials, Home Hub Smart Speaker, not with the other ones, but we do have a match with the industry report. So what I'm guessing, immediately what comes to mind is that this dataset does have the Home Hub Smart Speaker in this specific dataset. Yes, but for some reason, it's not matching with the others. So maybe the prompt is not matching the text of the others, right? So see here, the Ultrabook Pro 15, it added the new demographic information, but it matched the Home Hub smart speaker. So this is something that may happen also, right? So the Home Hub smart speaker definitely matches that portion of the document. This one doesn't. Or in fact, a different product is matching with the Home Hub smart speaker. What I'm guessing that happens is that there is a language association here. Because it's a laptop, it's associating the laptop with the speaker. And because of that, it's thinking that the best source of information, the closest source of information, is the information on the speaker, right? It's not a laptop, but it's the closest thing that you have in terms of text. Weirdly enough, the embeddings are not being created for the other documents, right? Because we saw in the indexing script here that yes, it created the embeddings for industry report. It did not create the embeddings for the Home Hub Smart, for the other products, just the Home Hub Smart speaker. So this is some sort of bug with the embedding model, and we can debug it. But you can see the lesson that we are trying to extrapolate here is how changing the level of granularity in how you tag your documents gets you different results, right? So first we didn't have any tags, and you try to find the specific sections within the documents. Then we did the generic tag, and then we had the marketing materials in general. And now we broke the marketing materials into the specific products, and now it's mentioning a specific product in a specific entry. We do still have some bugs about some products, for example, being matched with a portion of a document that is not exactly about that product, but it's about a similar product, like for example, laptop and speakers, or others that don't show up. But this is the generic lesson, right? I want you to see how the different levels of tagging reflect themselves in a different level of granularity in the text matching. So as we see, this is a very simple process, right? We follow the usual steps for the RAG preparation, and then simply we use an LLM to generate the augmented data to append to the dataset, fetching the most relevant part of the supplementary documents that were indexed by the RAG process. Let's talk about using RAG when we are using a GenAI model to generate metadata for a dataset. It's going to be the usual process. The only major difference here is that the supplementary information that we want to index with RAG are going to be metadata themselves, because those are the most relevant ones in terms of generating new metadata. Let's take a look at this process. Welcome to this lesson on using RAG when using generative AI for data operations related to generating metadata from existing data. Let's say that our use case this time is to document an existing dataset in terms of metadata. For example, a dataset of financial transactions. We don't have metadata for it, and we want to make the data steward's life a little bit easier by using GenAI. That's our use case. What elements are we going to need here in order to perform this task? Well, first the data, right? First, we're going to need the data whose metadata we want to generate. And then if possible, existing examples of metadata in the organization, just so the LLM captures the style, the syntax, and the specific format of our existing metadata so that it generates the new metadata in the same format. Then, the RAG data are going to be, for example, the data dictionaries, the glossaries, the internal documentation repositories, or the repositories of metadata or terminology themselves. In other words, any additional information that helps us generate those metadata. And then the prompt is going to be something simple, such as an indication of the metadata terms and the structure to use. Or you can either let the LLM figure it out from the existing metadata examples, but if you can be rigorous about what it should produce, even better. What would be the general process here, including RAG for this task? Well, first, we may define the metadata fields that we are going to need and for which data, right? So what are the type of metadata that these transactions need? Are we going to generate data sensitivity categories, access control rules, data retention policies, or anything else, or possibly all of these? Then we process the supplementary data to use an RAG as usual, right? The existing metadata, dictionaries, glossaries, and so on, right? So we transform them into text, we create embeddings, and we index the embeddings. Again, you know this by heart by now. Then we actually generate the metadata with an LLM, right? Filling in the descriptions for all data types, or the business purpose of those data or entries, or any other use case. We provide the prompt, we provide the datasets, and then the RAG mechanism is going to fetch the most appropriate information from those embeddings and include it with a prompt. Then optionally, we may want to harmonize the metadata as well, right? That is, we may run a second LLM pass to take in all the metadata that we have, the older metadata, and the generated one as well, and ensure congruency. In other words, you want to assume that the LLM is going to generate the new metadata in the same style, but if it doesn't, then you are going to need to fix them, if you will. And naturally, we want to validate the generated metadata. Usually, there's no automated way to do this. You can't run statistical analysis on unstructured text, for example, but you can copy-paste multiple sources of metadata into an LLM and ask, hey, what are the differences between these two? Or even have a human just take a look at it and make sure that the information really is congruent with what you already have. What would be some components of a prompt for this use case using RAG? You can say, for example, generate metadata using the same terms, the same syntax, and the same structure as the existing metadata in these specific documents, or let it figure out the style from the RAG documentation. Then you could say, ensure that you use the terms in this specific document or documents, not synonyms and not variations, these exact terms. And you can ask it, for example, to include documentation for all fields and all data types, or to generate data retention policies, or whatever your specific use case is, right? Because when we're talking about metadata, there's still possibly 50 different things that you may want to do. So just make sure that the documentation and the prompt match what is relevant to your specific use case. And you can also ask it to include data validity rules or possible policies for all fields. Again, it depends on your specific use case. These are just things that you can do here. So this time, we are going to generate metadata using RAG. And what we have in this case as support documents are actual metadata documents and documentation at the end of the day, right? So they tell us about specific definitions, they tell us about sensitivity levels, or they just give us contextual information to generate those metadata, right? Off the top of my head, I can already see that some of these are going to be more relevant than others for different purposes. For example, the compliance document is going to be very relevant when it comes to sensitivity levels, data retention, if we have that type of use case, while the data dictionary or glossary is going to be more about the data formats, the field definitions, and so on. Either way, let's get to work. Let's do a simple tagging system here, where we say, for example, data dictionary glossary, and then another simple tag file here that says compliance documents. Compliance guidelines, I guess. I don't know what is the specific title. Regulatory compliance guide. And you know the drill by now, right? Very simple example. We ran the indexing script, and it's going to generate the embeddings with the tags, regulatory compliance. Okay. Do we have the other one as well? No, it's just generating the embedding for the regulatory compliance guide and not for the other one, right? So there seems to be a little bit of a bug here. At least the tags are fine, but we saw this in the previous lesson as well, right? So sometimes you may have situations where the embeddings are not being generated for all documents, or there is a problem with how the text is being matched. Let me see if this is a problem with the tags. What happens if I remove the tags and I try to generate the embeddings again? Compliance. So it seems to me like this is not necessarily an issue with the embedding generation. Maybe it's a bug with how we're processing the files in Python or something like that. But either way, I wanted to restore the tags. Yes, we got the tags back. So let's generate the embeddings and let's work around this. And because we have a compliance guide, I think that the compliance guide was the only one that was mentioned or that was indexed. I'm going to have a use case that has to do with compliance so that we can use what we have in this section, right? Because otherwise debugging this and making this work for all use cases could be very time consuming. So please generate metadata for the fields. So what I'm going to do is I'm going to ask for some sort of metadata that has to do with compliance, right? For example, please suggest data retention guidelines for the various data fields and possible regulatory frameworks that apply to them. And I'm going to say something like, for every field, please include a bullet point on suggested data retention, a bullet point on regulatory frameworks that may apply, and document tags that most match this specific information, right? The document tags or the included document tags that most match this specific information. Because that way, it's going to generate those and it's going to tell us in specific what are the most relevant portions, right? Do we have the full prompt? Well, oh, actually the data dictionary or glossary was embedded and it's being included, but the regulatory one isn't. Okay? I'm going to consider that is okay, par for the course. Let's see, right? It may be the case where it was just showing us a sample, because I think that the indexing script, it does have some sort of test function at the end of the embedding, and maybe that specific test prompt was matching the regulatory one. So we can see here, data retention guidelines, regulatory frameworks, matching tags. The tags data dictionary glossary are relevant as they likely contain definitions or policies, right? So in this case, the result was the opposite of what we thought. It only included the data dictionary or glossary, and it included that tag and not the regulatory compliance one. Again, sometimes you have to debug here, because how are the document chunks being compared, right? How is the text being compared from one side to the other? It may also be the case that the file that has the data dictionary or glossary actually mentions regulation and data retention to a deep degree. So we may think at first glance that if we mention compliance and regulation in the prompt, it's going to match the other document, but maybe it isn't, because we don't know what are the actual contents of that document, right? This is a type of thing that would merit an investigation, see what is the language used in the embedding model, but we don't have the time for that, right? This is a quick example. This is just to show you, we generated the embeddings, and now it's matching them with the specific fields in that data dictionary or glossary. Let me see if I can break this apart. It has 8 sections, right? So I'm going to do something fun here. I mean, fun is a relative term, but I'm going to break this into 2 halves. Instead of 1 per section, which would give us 8 sections, I'm just going to break it into the first part of the glossary and the second part of the glossary. And then I'm going to see if that is reflected and how we get the tags, right? So sections 1, 2, 4, I think, 1 through 4, and then sections 5 through 9. And then we're going to have the appropriate tags, and we're going to see what it gets. Okay, so section number 5. So I'm going to cut all of this, and I am going to, in this one, delete the first 4, right? So this is another example, what I'm trying to do. It's an example of how you can break a document apart by chapters or by sections. You can decide what is the level of breaking or the points where it breaks, right? Section 1 for 4, and here I'm going to do exactly the same thing, sections 5 through 9. And what I just want is some sort of reflection of this in the result, right? In the prompt. I want the answer to say, hey, this specific chunk was matched with sections 1 through 4. This one was matched with sections 5 through 9. And here's what we can even do, right? If we go to these sections, what are these sections about, right? So 1 through 4, demographic data, insurance, clinical data, okay? And 5 through 9 is data classification and data retention. So here's what we're going to do. We are going to have 2 parts to this prompt, because the first one is about the definition of the fields. I'm very sorry. I opened the wrong file. And what I'm trying to do is I'm going to guide the prompt to tag the right things by asking for things which are in those sections, right? So what I'm going to do is, we know that sections 1 through 4 are about data formats, right? So please generate the following metadata for the dataset fields. A summary of data formats and some expected values, as well as the tags of the most relevant documents for this. And then another section, which is a summary of data classification and data and general data governance policies, as well as the tags of the most relevant documents for this. So I'm kind of doing a little bit of prompt engineering, because we know that sections 1 through 4 of the data dictionary or glossary are about the data formats, so they match this section. And then sections 5 through 9 are going to match this second section. Hopefully, again, right? I'm trying to do the prompt engineering on purpose to get to this result, just to show how doing a different level of indexing with different tags is going to net you different results. But again, I don't know if that is exactly what is going to happen, because we don't know the text contents, right? Just because a section says data governance, maybe it actually mentions the data formats a lot in the actual text, so it's going to get matched with the data formats, or the opposite, right? The title of the document doesn't tell you exactly what is going to happen, but it may guide you. Okay, so let me cancel this immediately, because I did something which was I forgot to delete or to backup the general document. So the general document was being indexed as an embedding without the tags, while we also got the sub-documents, right? So this is the type of issue that if you don't detect, it can cause a problem because, it's going to be included in the prompt and you're going to have multiple things matching. Okay, so what do we see here? We get exactly what we want, right? Emission date, sections 1 through 4, sections 1 through 4, and then in this other part, sections 5 through 9, right? So we already have the two portions of the document being matched. And the compliance document is not even matched with this prompt, which is exactly what we would expect, right? Because we didn't talk about compliance, we didn't talk about regulation, we just talked about these specific elements. Okay, so we have the summary here. I would like a mention of these tags, right? Are there missing fields that should be noted? I don't think so here. We have data formats. So we do have a description of the formats and values, right? It fetched the information from the dictionary and glossary, which is what we want to happen with RAG, but I want the specific tags. So here it mentions it, right? It mentions sections 5 through 9. Perfect. It didn't mention the tag, it mentioned the document name. We can tune this with a prompt, but it's already what I want in an approximate manner, right? I really wanted this to be explicitly stated, right? I want this to be section 1 with the specific tags of this document, section 2 with the specific tags of that document, but that's a bonus, right? And also notice something else here, which is the third document likely covers. So do notice that when an LM generates the answer, it only knows to a probabilistic degree what happens. So it knows, for example, that this section of the document is matched with data retention and data governance. So it thinks that it's probably the most appropriate section, but it doesn't know it exactly, right? It's not capable of saying, we pinpoint this to this specific section. No, it only knows this portion of the answer is associated in a probabilistic manner with this document section. So this is the language that it uses. Let me try one last attempt at being very, very specific, right? Please provide the answer split in these two sections. Please explicitly provide the tags associated with the documents that are the most relevant for each of the two sections. Please provide at least one tag per section. And again, I'm going a little bit far here, right? Because in a lot of cases, the only thing that you want from RAG is for it to use the text of the backup documents and enrich the answer. We already have that, right? So we're past that point. What I'm trying to do is I'm trying to force it to tell me exactly what is the section that is being included. So I'm being a little bit forceful here. And again, all types of factors influence this, right? We're using a small model. The model is not fine-tuned. There's a lot of moving parts here, right? Do we have tags? Okay, relevant tags. No. Okay, so this is on me. I didn't specify the prompt, right? Tags like patient data. I don't want these tags. I'm talking about the meta tags from the documents, right? So let's go back to the prompt. Please explicitly provide the document tags associated with the documents that are the most relevant for each of the sections. I'm trying to think. These are not generic tags, but the specific metadata tags for the associated documents contexts. I think that we call them contexts in RAG, so that could also be something that happens. So I'm just going to try and do one last attempt and make one last attempt to make sure that, or to increase the probabilities that we do get what we want. But you see how this works, right? We tag this in a different manner and we engineer the prompt so that we know exactly what we want to get from this portion of the document, and the portion of the document is being reflected, right? We see the portions of the document reflected. In certain cases, it's also probabilistic because sometimes when we change the query and we change the weights, we change the documents associated. You can see here that sections 1 through 4 were actually included 3 times in this. So it may be the case that we didn't get the other document. It depends on what the prompt is, right? But in this part, we don't have a tag. And in this specific part, do we have the tag? We don't have the tag, right? So it fluctuates a little bit. We cannot make sure that we get the tags in every single part, in every single portion. They are included because we do have them here. They're just not being passed to the answer. So when we see the internals, we see that the tags are there. It also depends on our use case, right? Do we just want to have a good answer with relevant information and accurate information, or do we really need that tag like that chapter number or that page number? And in certain cases, because we do have the tags here, because this part is programmatic, maybe we don't even need them in the answer, right? It could even be the case where we output the LLM answer and then we output the associated tags in a programmatic manner side by side with the answer. That could also be done. But you see how we did it, right? We changed the tags and we changed our prompt, and then the portions of the documents which are fetched with a search similarity index comparison are going to be different. So as you see, this use case also has a very simple process. We follow the usual RAG steps, right? We pre-process the metadata, we create the embeddings, we index those embeddings, and then the most relevant portions of metadata are fetched and used together with the prompt when we're using the GenAI model to actually generate the new metadata. Let's talk about using RAG when you are using a GenAI model for data transformation in specific, calculating the field mappings, executing the transformation itself, but using RAG to provide additional information throughout this process. Welcome to this lesson on how to use RAG when using GenAI for data operations when transforming data in specific. Let's say that our use case here is to migrate a set of CSV files, such as, for example, structured news data, to a specific internal JSON format. So, what are the components that we are going to need to perform this using RAG? First, the data, right? It's the data to convert. In this case, the CSV files to transform or to map the news data. Then, the data for RAG are going to be documentation of the target formats if we possess those, and optionally, any additional or supplementary news pieces or documents that help guide this transformation, that give us additional information about what is a target format. And then optionally, additional supplementary news pieces or documents that provide additional context or guidelines for that conversion. And then the prompt can be something like an indication of what data we want to transform, as well as how. What are the specific formats, what are the mappings between fields, or just criteria for the LLM to decide this on its own if you wanted to do its own thing. What would be the general process here to perform this task, including RAG? We start by assessing the transformation requirements, right? What is the current schema and what is the desired schema for these data? Maybe, for example, we want to have a source field, a date field, a competence field, and a sector field, which may exist or not. We may have to create some from scratch or adapt certain fields to other structures. Then we may optionally condense these guidelines as text for RAG use for the future, right? Documents that formally define these rules and formats. Because we may want to include these conversion guidelines in the prompt every single time, or simply create documents with those guidelines that we can embed with RAG. And that way, we don't have to always repeat ourselves in terms of those guidelines in the prompt, right? They're going to be fetched automatically from the RAG documentation. And if we want to use them in RAG, we have to pre-process them, right? Convert them to text. In this case, they're probably already text, create the embeddings, and index those embeddings. Then we simply generate the transform data with our LLM, right? Generating the new news data in the format with these fields. We include the prompt, we include the dataset, and then it's going to fetch those guidelines by RAG if we have embedded them as documents. If not, it's just going to look for them in the prompt. And if we have additional information about those news pieces or anything else that is relevant to help transform those formats or even enter additional information, it's going to fetch all of that with RAG as well. Or not all of that, it's going to fetch the most appropriate pieces of those documents with RAG. And then we may want to validate the generated data or run statistical analysis as usual. So we may run statistical analysis to detect completeness or accuracy issues, right? Just making sure, are all of the data there in the right format and do the data make sense? What are some components of prompts to perform this with RAG? We can say something like, please transform the data from this source format to the target format. Then please map data based on these specific mapping rules. Then make sure that these specific fields are present, right? If a given field has no value, induce that value based on the rest of the context to provide a justification and flag this value as being generated instead of transformed. And also, please ensure data integrity and the correct conversion of values, and don't change the original data. These are just some examples of components of a prompt in order to do this. So this time, for our final lesson, we are going to convert data and use RAG to help with this. So in this case, what we have here is a format for the JSON. We are going to have a data set of weather entries, and we are going to convert them to a JSON format. And what we're going to do is we are going to attach the file structure as RAG for that conversion. Why? because maybe you don't want to mention the structure in the prompt every single time. So you just include it as a document that is embedded with RAG, and then that structure is valid for every single prompt that you use in a data transformation project, right? You don't want to be copy pasting it into the prompt every single time or having it in the code because it could even be a vulnerability. It's sensitive data. So what we're doing is we're including this document, and then it's going to fetch the document, and then it's going to use that structure in the conversion, hopefully. So in this case, we don't even need any sort of tag, right? So I'm just going to open the scripts and to change the folder because I didn't change it since the last lesson. This doesn't need the current path either. Okay. So we also need to change the dataset path. Okay, because we made this script so that it can use the sub folders. Okay. And now let's run this. So does it index? Yes, it does index the target format. Again, this is a different use case because it's such a simple document. We just want the document to have the structure, and we want to embed that structure into the prompt with RAG. So here in the prompt, these windows are a little bit awkward. Okay. Hi DeepSeek, please convert the associated weather data dataset to JSON entries. Please use the attached JSON format. Now here's the thing. I am tempted to not include the structure and see what it comes up with, and to then include the structure and see whether it obeys. But it doesn't make sense, right? Because we already did a JSON conversion back in the lesson about data transformation. We saw that the JSON format was all over the place. I think it was with the news entries, if I'm not mistaken. So here, I'm just going to test right away. Does it obey the structure for every single conversion? Yes or no? Okay, so we have the prompt here. You know, we are just going to do the conversion, right? It's fetching the target JSON document, right? But it should, because we're just asking it to convert to JSON. So it would probably match with this document since we are mentioning JSON. And now we have the list of entries here, and let's see what the output is, right? It's going to take a little bit as usual. It's funny because we only indexed one document in this case, and it's still taking some time. So I don't know if this is time that is taken with the generation of the actual answer, or whether the mechanism that embeds the answers or that does the matching has kind of a constant time consumption. But we can see here that it did the conversion, right? Now here's the thing. Does this structure match the structure that we have? I think that it doesn't, right? Because if we go to these documents, it must say metadata and weather data, right? Okay, converted into JSON entries using the requested format. It's not using the requested format at all, right? Contains all the weather data points with each station's measurements. Okay, so I'm wondering if we should specify something here. Metadata, information about the dataset itself, weather data, array of weather observations. Well, this is pretty clear, right? There is nothing else that I can add to the prompt that will make it clearer. I'm just going to prompt harder, right? Please use the attached JSON format. Please use the attached JSON structure. Please obey the fields in the structure. Do not generate JSON in other formats which are not dimension 1. So here's the thing. It is already including the RAG data, so it is a success in that sense. It's just not obeying the prompt, right? So it is a problem, but the complex part is already taken care of. We are indexing and we are fetching the relevant RAG documents. Now, the issue that we have is just that the LLM won't obey, which is just another day in the life, right? If you think about it. So it's just about prompting harder and getting it to really give us that output at the end of the day. And if you want to run this in the pipeline in the future, you can do all of the other things that we mentioned in that module about the pipelines, right? You could have some sort of validation where you try to parse the response as JSON. Does it have the metadata field? If not, then just repeat the answer for 10 times or 15 times in a row until we get that, right? JSON. Okay. JSON entries based on the provided structure. It's not using the provided structure, right? So a JSON object such as, let me do the following. Is it getting the document? It is getting the document, right? What may happen here is that because the structure is mentioned as text, and this is about matching tokens, maybe it's actually not getting the portion of the text, but it should, right? It does the matching and it fetches that whole portion, so it knows the structure. It does know the structure. So I think it's just not obeying. I need to make sure that the station's data is an object within a JSON array. I think that, okay, something else here, which is I said don't use any other format except the one mentioned, and I was talking about the structure, but it interpreted that as JSON. Don't use any format except JSON. That's not what I meant, right? Let's do the following. So we see that it's thinking a lot about the specific elements, and it's thinking a lot about the number structures and all of that. So what I'm going to try to do is give it a little bit more of guidance, right? I am going to try and give it a little bit more of guidance in terms of the fields, right? Please output the metadata field as blank and all of the entries within the other field within the JSON. So what I'm essentially doing here is I'm trying to guide it inside the format, right? Because it seems like it's not obeying the structure. So I'm kind of using more of that structure in the prompt to try and force it to adopt that structure, whether it wants to or not, right? Worst case scenario, we'll just copy paste the structure into the prompt to see whether it's a problem with REG or not, but I don't think it is, right? The REG part is working. It is fetching the relevant part of the document, which is a JSON format, but it's just not obeying the prompt, right? It could also be, and this happens sometimes, there's a conflict, which is it's trying to convert a list of entries to a JSON, which immediately tells it it's an array in JSON. But then we have a format which is not necessarily an array. It's a format with sub keywords, right? So it is converting to JSON. It's not just converting to JSON in the way that we want. Let me try one last thing, which is to get it to state the actual format here, right? Please output a JSON object that has a metadata field that is empty, and then the entries within weather data subfield. So I'm pretty much repeating the format in the prompt besides the REG document. I don't think that it's going to make a difference. It's ignoring the structure. But again, I think that it's ignoring the structure because there's kind of a conflict in terms of the prompt conversion in the format, right? The prompt says convert this to a JSON, and it thinks it's a table, so it must be an array. And at the same time, we're giving it a custom structure. So I think that the conflict is with the prompt, not necessarily with the REG fetching, right? The REG fetching is working beautifully, but still, I would just want to vet that that is in fact what is happening here, okay? So we're just going to wait a couple of seconds until this generates the answer, I guess. But you can see how conversions in specific are a little bit tricky because LLMs usually deal with text. So we're going to wait a couple of seconds here to see how it does the conversion. But you can already see that there's, a little bit of trickiness involved when we're dealing with data formats because the LLM may not be fine-tuned on a specific type of format, or it may not want to obey that format, or it may insist on doing something like an array. In this case, it's not that serious because we could circumvent this, right? If we're talking about metadata, we could use one LLM answer for the metadata and another LLM answer to generate the weather data within the array, or to generate the array and put it inside the weather data. But for some reason, it actually output. Okay. And it didn't tell me. So it got a little bit better, right? So weather observations and metadata. It didn't give us the full text structure, but it's a step in the right direction. Again, it may be a situation where the data set is too complex, or maybe we should do two passes, one for the metadata, another for the array, but it's doing the conversion. And more importantly, it's fetching the data from the REG document as we want it to. Now it's just a matter of, pushing in a combination of asking less things at the same time, prompting in a stronger manner, or just doing more LLM passes, or having a more potent LLM. And that combination of factors will eventually give us what we want. So as you see, the general process is pretty much the same as usual. The only major difference is that the information that we are pre-processing using REG is going to be information that is relevant, either with the specific schemas or transformation guidelines or others, which are going to be valuable information for the transformation itself. And with this, we are now at the end of this module on REG for data quality. That is, not just how to use GenAI models for data-related operations, but how to use REG to attach the most relevant pieces of information to improve the quality of those LLM answers. As usual, let's take a moment to cover the topics and key takeaways from this module. We are now at the end of this module on using REG for data quality, where we covered how to include additional information with RAG to mitigate hallucinations and improve LLM answers for data operations. What was our major focus in this module? Well, for example, we touched on what is RAG, or Retrieval Augmented Generation, how it works together with LLMs, the benefits, how the pre-processing and creation of embeddings is done, and the general process for using RAG. Or, for example, various use cases of using RAG, such as to complete data, augment those data, generate metadata, and more, as well as the general process including RAG. Or, for example, appropriate prompts, data sources, and the steps of the process itself for these various use cases, including the pre-processing of various types of documents, as well as the generation of LLM answers themselves with specific prompts. What are some key takeaways from this module? Well, we generate embeddings for RAG, for example, with a specific model. This means that this module can be fine-tuned and must be chosen just like the LLM model itself. And it should use the same language as the LLM model and the prompts in the documentation that you use in RAG itself. Then, the only way to track answers to a specific document chapter or section is to actively tag those chapters or sections when you are creating the embeddings. If you don't, you can't track them. Keep this in mind. Then, just like for LLM training, the information that you are going to be using and embedding in RAG must be updated and correct, because otherwise you are harming and not helping. And when dealing with data formats, rules, and others, besides the contextual information in the documentation, we must also specify the specific formats or the specific value ranges or the rules that we desire, because the additional documentation that we include is going to provide more context for the LLM, but it's not going to give it instructions, because the specific information that we include with RAG is going to provide additional context for the LLM to estimate something or to guess something, but it's not going to give it instructions. So having clear prompts is still a best practice, and especially with RAG. And with this, we close this module focused on RAG, how to use RAG for different specific use cases in terms of using GenAI for data operations. And with this, we are now at the end of our course on using generative AI for data management and data remediation. We've covered a lot of different use cases and a lot of different operations. Let's take a moment just to recap what we covered in terms of the modules and their descriptions, as well as ask some final questions for you to reflect on these practices. With this, we are now at the end of our course on generative AI for data management and data remediation. What were our major learning objectives and goals in this course? Well, we wanted to understand certain things such as, for example, how data quality, the data lifecycle, and generative AI work in general terms, the fundamentals of these disciplines. Then, how GenAI can help you create or ingest data with high data quality, completing values, extracting schemas, automatically defining rules, and so on. Or how GenAI can help actually remedy data, cleansing those data, augmenting them, detecting anomalies in them, performing data profiling, and more. Or how GenAI can help transform data, right? Detecting schemas, mapping fields, or transforming datasets. Or how GenAI can be integrated in real-time pipelines themselves, right? Automatically correcting data, transforming them, and so on, without you needing to ask a question of an LLM, copy-pasting the result, and doing this in an automated manner. Or, for example, how RAG can enhance LLM answers at the various stages. How you can use RAG and additional information to complete data, transform data, and a lot more. Finally, what are some questions that you can ask yourself to reflect on these practices? For example, how do we track data quality issues in our organization? What efforts do we make to increase data quality? And in which operations can we easily insert generative AI? Or, for example, what text generative AI solutions do we have at our disposal? And how easy are they to run and to integrate? What is the best one to include at this point? Then, what documentation can we leverage in RAG? Is that documentation timely, correct, and does it have consistent terminology? Not just in general, but what documentation can we use for RAG to fix a specific dataset or for other specific use cases? Where can we create one or more automated pipelines with GenAI to increase data quality? Where is speed or scalability not going to be an issue? And where can GenAI really help us and take the effort off of human hands? Or, at the end of the day, in which data-related use case or remediation operation can GenAI cause the biggest impact on right now? And with this, we close this course on generative AI for data management and data remediation. Thank you so much for your time, and congratulations on reaching the end of the course. And I truly hope that this course has given you additional tools and knowledge to take your data management and remediation practices to the next level using GenAI. Thank you once again.